Are we live? Okay, great. Monday morning, 10 a.m., first talk of Dappcon 2023 in Berlin. And I'm personally happy that it's this early and on the first day because I get to like party after at 11 o'clock this morning, which is good. So do you have your computers with you? And I just wanted to ask, would you like me to walk with you to try to install? I'm going to talk about TrueBlocks, which is the project I've been working on for about 6 years. The fundamental idea behind TrueBlocks is why is the Node software so hard to use, and what would we have to do to the Node software to get it to be better so that it would be a better data server. So I'm going to start the talk by having you install TrueBlocks, if that's what you want to do. It's optional for you. You can follow along, and I'll jump right into that. Then I'm going to talk about running running the Node software locally. How many of you have ever run Node software locally? Any? All, but maybe, have you? Yeah. Did you run it on what kind of machine? What kind of machines were you running on? Mainnet Ethereum or what? Yeah, that's great. That's amazing. And did you guys run the server yourself? You've run many servers. Yeah. So I'm actually running a REST server here against Sepolia. So I'll show you what that looks like. And part of what I wanted to say is that running a server is nowhere near as hard as running a node software is nowhere near as hard as people think it is. So I'll just jump in and get started. If you all go to this page, we can kind of follow along. So do you all have build environments basically on your machines? Go language, do you all have Go on your machine? Who doesn't have Go on their machine? Why don't you visit the Go site? Maybe you can try to catch up. I won't wait for you to. Okay, great. And you all have Git, I imagine, and you all have CMake. Do you have CMake on your machines? Okay. So I'm just going to jump right in. I'm actually kind of amazed that you all run nodes. Can I ask, like, why do you run your own node?
I want to do blockchain indexing.
You want to do data analysis, or you just want to do like after indexing, then you want to get data?
Yeah, for data analysis for investment purposes.
Yeah, you want to look at addresses and see what they're doing, kind of.
Yeah, exactly.
Yeah.
So who buys what, when, and so
Who buys what, when, and yeah.
do a kind of cluster wallets.
Nice. Have you tried TrueBlocks yet? Okay, great. And you guys, why do you run nodes yourselves?
For Oregon, is that we have one, and private to state.
Do you run a node, you said?
No, but I work for a company that provides nodes as a service.
Oh, okay, great. And indexing is something that you're interested in, or?
Yes.
Yeah, and I know these are all Rotkey people. Oh, a little bit of a shill here. Rotkey, pick it up. It's a great piece of software. So I tell people that accessing the data from a locally running node is orders of magnitude, and that's 2 at least orders of magnitude, in my opinion, better than hitting a remote server. Nothing, present company accepted over here. And I say that running an Ethereum node locally is not as hard as people think. And even if you do run an Ethereum node locally, you'll find that the RPC doesn't provide probably what you want it to provide. It doesn't give you access to histories of accounts. So that's what TrueBlocks tries to do. So I'll go a little bit light. Is everything good? So there's a number of things for me that Web 2-like APIs and Web 2-like access to data doesn't agree with the Web 3 ethos. For example, rate limiting, and we're going to see an example of that in the demonstration. They kind of have to know who you are so that they can rate limit you. If they don't know who you are, they won't be able to rate limit you. So all of those things kind of make me want to see if we can't do it a different way. So let's get started with installing TrueBlocks. So I'm going to skip down here. And if I'm just going to go and do these commands, and you're more than welcome to try to do them yourself, unless you already have it installed. So this is downloading and installing TrueBlocks on my machine from Git. And then I'm going to CD into that folder, make a build directory, and change into that folder. Type cmake, and then type make. So I'll just show this again. If you want to go through these steps, and when you get to the place where you can say that the ls-l shows you Shifra, then I'll continue. Just go on. Are you following along? Yeah. Are you all at the place where you have Shifra installed or built? That was amazingly quick. Type Shifra and hit enter. Can you? And you get a screen just showing you a bunch of stuff. Is that true of everyone? Should I wait or should I proceed? I guess I'll just proceed, and then if you want me to stop, you can just ask me to slow down or back up a little bit. I've already shielded your, I held this up to the whole world. So once you have it installed, you have to, it's going to make the rest easier if you put this thing in your path from the build folder. And then you can run Shifra version and Shifra status. And just give me a thumbs up if you have it running. I got 0 thumbs up, so nobody's running it. So 1. Okay, good. We got 2. As soon as we get 3, we're going to move forward. 3. Shall we wait a minute, you guys? You're from Gnosis, you guys?
Oregon.
Oregon?
Yeah.
Oh, sorry.
I'm sure we need to set up my VA
I should have.
show my hand.
That's all right. So we're actually working on a Docker version, so it would just become a one-line command. But so I said that I was running my own local node. So I just wanted to spend a minute and show you that. So what I did to run my own local node on this laptop, which has a 4 terabyte hard drive, this laptop, is I just went to Reth's GitHub repo, and I downloaded the GitHub repo for Reth, and then I typed a single command. I just typed docker compose up, and Reth starts. And it opens 5 pieces of software. So this is Reth starting. And it opens 5 pieces of software. One is the consensus layer. That's here, I believe. Yeah, this is Lighthouse. That's the consensus layer. It runs 3 pieces of monitoring software, and it runs the execution layer of Reth. And this, I think, is really nice because I can open up a panel that shows me that Reth is syncing. And this makes, I don't know if you've ever tried to run a node, trying to figure out if it's actually syncing is really a pain in the ass. So This is really beautiful. I just leave this open. It constantly updates. And when it's synchronized, now I can start using this node. So this is synced against Sepolia. So you can see it's blocked 4,200,000. Is everything okay? And this was as easy as it could be. It took a one-line command. It's up and running. It's in Docker. As soon as Docker starts, Reth starts, and it's constantly running, constantly updating, and I don't have to do anything. So Vitalik once called the node a big, hairy node. And I'm like, it's not that hairy, and it's not that big, so you should try to run it. But so I just wanted to show you that, and I'm ready to move on. Is everybody ready to move on? Should I move to the next step? Well, that's the least responsive audience I've ever seen in my life.
Yes, we're ready. I'm good. Ready.
Okay, thank you. I'm going to move on. Thank you. So, type Shifra status on your command line. And it's going to show you, I just wanted to point out, it shows you what node you're running against. It shows you what release of TrueBlocks you're running against. It shows you what chain you're running against. It shows you a bunch of folders that are useful for configuration. And it shows you some numbers here. So these numbers are, this is the head of the chain. That's the head of the Gnosis chain. And for this installation, this is our index. This is how far along our index is, which is not far along at all because we just started. We didn't do anything to get the index. So we're going to try to get the index. You can try to type this command in your browser, in your command line. And I'll type the same command. So after it downloads a file, it's downloading a timestamp database that we publish because timestamps are a real pain in the node. One of the real shortcomings of the node is that it doesn't really give you an easy way to get timestamps, get block data from a timestamp. So this is saying that TrueBlocks is not properly initialized. Is everybody there? Do you see that message? Again, moving forward without any response. The next thing you can do is, it's telling you that you need to scrape the chain for the index. So I'm just going to spend a minute telling you what we mean by that. So let me go here. Oh, shit. Sorry. I'll be with you in a minute, sorry. So I just wanted to take a minute to tell you about our index and how we build it. So I said earlier that Shifra has a whole bunch of different commands. Some of them are related to building and managing the index. Some of them are related to, once you have the index, getting access to the data about particular addresses. And a lot of them are related to just getting plain blockchain data. So what we did is we took the RPC and we kind of said, where is it inadequate? And it's inadequate in a lot of places, but we added features to the RPC, basically, that allow us to do certain things. And one of the things that we added was a command called unique. So we have a Shifra blocks. It's exactly the same as the RPC endpoint for ETH_get block. And we added a unique tag, which allows us to look at every single bit of the data in any given block and pull out every unique address that appears in that block. And this is the basis for our indexing. So we basically scan through the chain, one block at a time. We do it in parallel, we're in Go. So we do as many blocks as we can at a time. And we're just pulling off addresses that we find and recording which block and which transaction they're in. We don't pull any other data at this time because we don't want to create a giant database that's a full extraction of the data from the chain. We want to create the absolute minimal index so that it stays on a small machine like a laptop. And that's in the unique feature. And what this does, basically there's two different kinds of places where the data could be. It's going to be in things that are very clearly addresses in the block. One is, all of these are pink, all these pink things are things that are, they're defined in the data as addresses, so we know that they're addresses, so we pick them off. There's a whole bunch of other places where there's just long strings of byte data in the block data, the trace data. And we do something a little crazy, kind of crazy, I guess, because I don't think anyone else does this. What we do is we take advantage of the fact that solidity, did I lose my connection? We take advantage of the fact that solidity packs addresses with leading zeros in byte data. And we can get these strings of thousands of bytes, and they might have hundreds or thousands of addresses in them, and we scan every single bit of all of that byte data, and we're going 32 byte chunks at a time, and we're saying there's a bunch of leading zeros there. And what we do, we know that this is potentially not an address. It doesn't have to be an address. Every 32 byte string is actually a valid address. Well, no, it has to have leading zeros. So we can chop off anything that doesn't have leading zeros. This one, for example. And if it has enough leading zeros, we say it appears to be an address. We don't say it is an address, we say it appears to be an address. That's why we call them appearances. And what we get, but then for some things we say, this does not appear to be an address, so we don't accept that as an address. And we throw out anything which has too many leading zeros, and we keep anything that has just enough leading zeros. And what we get is an index that is richer, and by that I mean it contains more than other indexers find. And I think that's because they don't even look in that data because they just think it's unintelligible byte data. But we're kind of, it's not a perfect solution because there literally cannot be a perfect solution because any 32 byte string is a valid address. Even 0001 is a valid address. So there is no perfect solution, but we want a solution that's as good as it can be so we can get as many appearances as we can. And we looked at Etherscan. They provide 7 endpoints for getting various different types of lists of histories. And we compare ourselves to that. After taking duplicates out of their entries, we get, on average, about 13% more appearances than they tell us happened to an address. And I think this is not only Etherscan, I think it's a lot of indexers are not looking deep enough into this byte data, so they come up short on their index. And when we look at where exactly it was that we found things that they didn't find, it's always in the byte data. So we're definitely finding some stuff that other people aren't finding. And then when we look at what exactly was that byte data, it's things like this. It's monetary things. Purchase, mint, trade with hint, split, donate. Those things are being missed by the major indexers because I don't think they're digging deep enough into the byte data. It's as simple as that. So we want to create the best possible index, recognizing that you can't create a perfect index because of that byte data problem. And then we want to build the index, and we do something a little bit different here as well. So this is block unique, and we're getting random distribution of addresses because they just appear as in a transaction as they come. It's time ordered. And an index, of course, wants to be sorted. But as soon as you sort this index, you lose what I call immutability or reproducibility or a proof or something like that, where if we were to take this data and put it into IPFS, it would stay the same forever. If we were to take this data and put it into IPFS, it stays the same until we add a new record, and then it changes on IPFS. So for us, that didn't work because we didn't want to build something that lost that reproducibility. So we came up with a pretty simple solution, actually. We just stop adding records after a certain amount of time. And we do this pretty much exactly for the same reason that blockchains stop adding transactions to blocks, because they want to create a fixed place in the world, a fixed bit of bytes. So we take the list of addresses, we sort them, and then we chunk them into chunks of index pieces. And we call that whole process scrape. So I'm going to go back to my command line and type Shifra scrape, because we don't have the index locally, and I want to build it. And it's telling me, hey, it's really great that you want to scrape, congratulations. You can't do that because your remote RPC provider doesn't provide traces. And I'm saying we need traces if we want to get a full index. Now, we could turn this warning off and let people build an index if they wanted to without traces. And now you're going to get logged. Basically, you're going to get logs or from and to addresses in the transactions. But that's 60%, I don't know the number. It's 20% less than the total. So you're going to miss all these important transactions that are actually transferring value. So there's an alternative. So we bump into this problem. And basically, Web 2 providers, they give you access to their sorted index, which puts them in a position of power towards the end user, which is something I wanted to avoid. So you get this end user is totally dependent on this web API provider to continue to give them data. They're also dependent on them to make sure they get valid data, true data. So I wanted to avoid that situation. Our first iteration, we didn't avoid that situation at all. We just gave people web access to our chunked index, but that didn't feel right. So then we kind of set the user aside for a second, and we said, let's publish this data out. Because it's immutable, let's publish it out to IPFS and keep track of all the hashes that we've created for each chunk, and then put that in what we call a manifest. A manifest is a list of every one of the chunks. And then we publish the manifest to a smart contract that we call Unchained index. And now what I've done, or what we've done, is we've created an index that is represented by a single 32-byte hash that any person on the planet Earth that has access to smart contract, which is every person on Earth, can bring down to his own computer, her own computer, and they have a list of every piece of the entire index. And I can't take it back after I publish it, and that's on purpose, because I want to eliminate my ability to become the controller of the situation. I'm giving away the control on purpose, because I want to, I'll show you why I do that. Now the user can say Shifra init, and then he can use some other tools from Shifra and build his application. Now the trouble with that, it's about 100 gigabytes big. So I'm going to come back over here and type Shifra init. You can do this if you want. It should work on your computer if you want. It doesn't bring 100 gigabytes down. It's going to bring only 3 gigabytes down. So how many of you have heard of a Bloom filter? So Bloom filters are astonishing. They take megabytes of data, and it's a list of addresses, and it creates from a megabyte or 50 megabytes of data, it creates 50K bloom filter. And because it's immutable, I can put a bloom filter in front of every chunk of my index. I put that bloom filter into the manifest as well, so when users download the manifest, are you with me? Sorry. Are you with me? Great, thanks. I just didn't know. Who's with me? How's it sound? Sound like it might work? Sound like it kind of works? So creating these small bloom filters that I can publish to a smart contract. Everyone can read that smart contract, pull down the list of bloom filters, bring them local to their own machine. And now they have exact understanding of where in the history of a chain their address that they're interested in appears. So let me show you what that looks like. So did anybody here run Shifra init? And is it running? It's gone through? How many, yeah. Yeah, you can type Shifra, config edit, and there's a section there for mainnet, and you can add your RPC endpoint there. You also have to change the default chain in that file to mainnet. I'll show you what that looks like as soon as this finishes here.
Then the bloom app is like compression on top of chunk of addresses.
It's so interesting what it is. It's like, it's a bit string, so it's ones and zeros, and I can take any address and I can hash the address, and then I pick five bits out of that hashed address, and I light them in the bloom filter. So if I put 2 addresses in, it might light 8 bits. If I put 10, it might light 30 bits or something. So when I query the bloom filter, if I hash the address again and I look at the same 5 bits, and if it says yes on all 5 bits, then I know that it's in that chunk.
So it's like
You should read about bloom filters.
it's like
They're-
a hashing.
It's super compressed. Basically what it says to you is the address that you're asking about or the data that you're asking about may be in the larger piece. It can say it's absolutely not in the larger piece because one of the 5 bits is not lit. But if it says 5 bits are lit, it's not saying it is, it's saying it may be. And it's really a magnificent thing. You should read about it. So now I'm finished, and now I have all of these blooms, and I have 3 gigabytes of data on my hard drive, and I have a bloom for every one of the chunks. And now I can query against the bloom filters. And I'm going to do that here. I'm going to say Shifra list TrueBlocks.eth. And this is saying I hit on these 7 bloom filters out of the 1,000 that I have. I hit on only 7 because TrueBlocks.eth only interacted with Sepolia in those locations in the chain. And it then downloaded just those 7 chunks. So out of 2,000 chunks, or 2,000 full chunks, in order to get a full history of TrueBlocks.eth on Sepolia, I download 7 chunks. And now I have 7 chunks on my machine. I have all the blooms and 7 chunks. And what I would love to see happen is, sorry. And now, if any of you have any of you done Shifra init and then Shifra list? Have you? Yeah. So when you did it with your address, and you got a totally different set of chunks because you have a different history. And this is done on purpose because I want each user to be pulling their own weight. They bring their own list to their own machine. There's false positive rate, which means that they get a little bit more than they really need for their own use case, which makes them a contributor to the system instead of a drain on the system. They're carrying part of the data. And we can turn on a switch that makes it pin by default. So once they have the chunks down on their machine, we can have them pin this data down on their machine. So what happens now is everyone is sharing in the burden of the data. And we don't have a situation where one entity has the index. And I wanted to build that on purpose because I wanted to explore what it would be like. And it actually works. I think it works if I get adoption and I can get people to use it. And it has all these amazing qualities. So I'll talk about two. One is unlike a Web 2 API, where if let's say I get 10,000 brand new users in one day, I literally have to go out and buy new machines because I have more and more and more people hitting against my central place. And that's why you need rate limiting. You have to keep people from hitting on it too hard. But if I get 10,000 new users here, we have 10,000 more copies of these pieces of the index out there. So the more and more and more people that use this system, the system itself becomes more resilient naturally without anybody having to do anything, and that's really important. The other thing that's very important and interesting is I have 10 chunks because I'm just a little guy doing little things. Uniswap is in every single block on the mainnet blockchain, and if they use this, they would download and pin the entire thing, which means that a heavy user of the chain carries a heavy burden of the data, and they should exactly do that. They shouldn't impose their use case on us without giving back to the community by sharing this index out there. So those two things are very important to me. They're not really something that TrueBlocks does. It's just something that IPFS does. This is just how IPFS works. Yeah.
Well, what is the concept of apps? Because it says app and...
Oh, I shouldn't use the word apps. It should say appearances. I found those many appearances in that line.
Yeah, when I did the list command, it said the happening for apps.
Yeah, apps, I should use the word appearances. What it's saying is in this chunk, I found 23 appearances or something. So is everybody with me kind of on this thing? This is kind of the thing I wanted to really get forward is we don't have to rely on web APIs to give us this data. We can build, all of this could actually be built into the node software so that it did this automatically. We can pin it on any content addressable storage we want. We can publish to some smart contract, and everyone can benefit from and help deliver this data to each other. So now I have on Sepolia TrueBlocks.eth transacted in these locations, and I know exactly what locations they are, and I can do something like this. I can cut off the block. I can get rid of the header. And now I have a list of just blocks. I'm going to store that in a file called blocks. And then I can do a command like this where I say state. I want to do state for TrueBlocks. I want to get basically the balance for TrueBlocks on Sepolia at every one of those blocks. Now, I don't have any money on Sepolia, so it's all coming up with zero balances. So I'm going to switch. Let me just do this. I'm just going to turn this off for 1 second. So I'm going to say, I want to see TrueBlocks on mainnet. You'll allow me to log into a different computer to do this, but so on mainnet, TrueBlocks has 4,000 transactions. So this is showing me the balances at every one of the blocks where I appear in the chain's history. And this is the basis for the next thing that I want to talk about, which is what I call reconciliation. So you'll notice there it went up to 76 for a minute. We got some funding from the Ethereum Foundation, so that was very, very helpful. But if you have, and remember I said that we have 13% more transactions, we find that, and a lot of those transactions are financial in nature. And the reason I'm interested in getting those transactions is because I want to know at every block where that address transacted, what was its balance, either in Ether or in any token. So I can actually also say, I can say Shifra, names, DAI, stablecoin. I know it starts with OX6. And that's the DAI stablecoin. So I'm going to take that. By the way, you guys are supposed to be following along with me, but I kind of lost you, so I'll just continue on. So I'm going to say, I want to see the token balance for DAI, for TrueBlocks, on all of those blocks that it transacted in. Token balances, don't know anything about Ether balances, so I'll take that off. So this is my holdings in DAI, or any token that I want to look at for every place where this thing transacted. And now my goal is to say, how do I know that the balance at the previous block was the same as the balance at the beginning of the next transaction, because that would be reconciliation to me. So I can say, I know it was $10 here. 2 months later, it was also $10, and now I know that I didn't miss a transaction in between. And then within each transaction, I want to say, beginning balance was 10. I spent 3. Gas was 1, so I better have, whatever that is, 6. So that act of reconciliation, to me, is a demonstration that I have a complete list of the history, and I haven't missed something. And then you can actually extend that. It's not just balances of tokens. It's not just balances of Ether. It's actually state changes in a smart contract. So I can say, I know that the number of votes was 200. I know that in the week of June 1st, 3,000 new votes came in. I better have 3,300 votes or something. And you can reconcile state. And to me, that's the whole point of a blockchain that has literally perfect state management for 300 million accounts, 100 million smart contracts, however many. On-chain, it happens every 12 seconds. Off-chain, nobody knows what the hell's going on any of these smart contracts. They kind of have a feeling that they do, but they don't know in depth because they can't reconcile what's happening off-chain. And to me, once we get to the point where we're reconciling state changes off-chain, I think then we get adoption, in my opinion. Because if I'm a business person and some guy comes along and says, hey, you know what? We're pretty good with the accounting. We're about $10 off here. I'm going to say, no, we're not. We're not going to a smart contract. You have 18 decimal places on chain. Give me 18 decimal place accuracy. And when we do that, I think we'll get adoption because it's a better accounting system. So off the soapbox, I have all the time in the world. I have 20 minutes left, so all the questions, yeah?
The reconciliation is based on transfer event, so you look for
No.
balance at beginning next.
I don't look at any particular thing. I look to see if the address is present in the transaction. And if it is, then I know that I have to reconcile something in that transaction. It can be a transfer. A lot of times it's not a transfer, which is why regular Web 2-based accounting people are coming up short on their ability to reconcile your endpoint, because They're looking only at events. If you look only at events, you're going to miss things, and it's not going to reconcile. And kind of the reason why I know this is because I started from reconciliation. I wanted to reconcile first, and every time it didn't reconcile, I went and looked for the place where something changed. And it was always in this byte data. And it was frequently not in event data. So you can't really reconcile with just events, even though that's kind of the theoretical way that it's supposed to work. It doesn't work that way. That's why I kind of say that you have to have tracing, that you have to dig as deep as you can, and if you miss something, it's just not going to reconcile.
So, because the wrapped ether contract is notorious for that, right?
It is.
Have that event emitted or
Yeah.
withdrawal.
Yeah.
Are you saying that out of the box, this is already seen and reconciled?
Well, we're definitely going to find that appearance, right? Because we're not only looking at events, we're looking at just appearances. We know that it's in there, in that transaction, something happened. We don't yet know what. But I know that we can look through, we now have, we're at that transaction, and we've been keeping track of balances for 50 tokens in the history of this this address. And we can say, let's look through the data and see if there's any tokens in there. And we have some heuristics on how to find the tokens. If they respond with a name, then we think it's a token, and we try to balance it. We have every address that's in that transaction because we have that unique thing. So we say, we don't really know what happened. Do a unique, give me all the addresses that are in here. Any of them that are tokens, I'm going to try to reconcile them. I first do a balance against the previous time I saw that token, and then I do a balance against the current time, and if it changed, then I know I have to reconcile. And I reconcile by doing everything I can to reconcile, looking at events now, looking in some data. We try not to do particular things for particular addresses. So if I fail and I get to the end and I can't reconcile, now I make an entry called correcting entry. And it comes out in the, in the data that here's the thing that maybe the accountant wants to look more deeply at or something, because we can't figure it out in a generic way. I never wanted to make it specific for specific addresses because that's not sustainable for me. But we're thinking about how we can extend, allow you to extend and say, I know this address, do this thing to get the balance, right? So that's in the works. It's kind of not yet ready, but yeah.
So in this case, for wrapped ether, you would have to add some custom logic.
I'd have to look at it. We might be lucky that it kind of comes out in one of, we probably have 10, I said that we didn't have any special cases, but we might have a couple of special case code where we know that it's weird like that. The more popular things we'll do. But we try to avoid that because it's not really sustainable.
But no matter what, it gets flagged at the end so that you know something.
Yeah, either we reconcile because it all makes sense and we find why it reconciles, or we say we can't reconcile, make an entry that sticks out as something weird is happening here. Any other questions?
Related question in the Discord. So that means, for example, I asked for Uniswap, for example, when I want to get all Uniswap trades, so who traded coin X and coin Y, so there is, in this process, there's no need for custom logic for all contracts. Because there are so many different DEXs, for example.
Well, it's so interesting. It's an excellent, excellent question. Really, truly is a great question. Here's the thing. Every single one of them, every single one of those custom weird shit that's happening, every single one of them is trading tokens. ERC20 tokens, almost always ERC20 tokens. And we look at ERC20 tokens, and almost all the time, we can reconcile on the change in balance of an ERC20 token. It may or may not show up in an event, but we know that the token balance changed from beginning to end, and we can say there was a token transfer of some type here. If it's positive, that's a mint maybe. If it's negative, that's a burn. If it's a transfer, it probably showed up in the transfer event. So all those crazy things that you're talking about, I was kind of lucky when I discovered that it didn't really matter because we just look at tokens.
And this is in the ERC20, this is get balance. This is
It is.
it calls get, this is kind of, you get the balance and then you lock the balance all the time.
It does.
You get the address.
It does, yeah. It turned out, I mean, I was worried about that problem, because everything's, slightly different and in just the tiniest little way. But it turns out that what they're doing down at the bottom, even a transaction that has hundreds of calls to hundreds of smart contracts, all of them at the very bottom are just transferring tokens. And we can kind of reconcile if we look just at tokens. It's not perfect, but if it doesn't work, then we give a special entry called, balancing entry or correcting entry or something like that. So, yeah, it all came from my desire to reconcile, right? So every time it didn't reconcile, then I went and spent 3 days trying to figure out where was that little mistake or where was that thing happening. So that's where it all came from. So anyway, people, they say, why so many files on my local computer? I don't like that. Or they say, how inconvenient, what a pain in the ass. And to that I say, yeah, well, tough. It's tough luck, It's like, if you want to be in a decentralized world, the first thing you have to do is decentralize the world. So that's just part of the game, is that you have files on your computer that you might not have had otherwise. Other people say, I love the command line, but I really love an API. So one of the commands that's available from Shifra is called serve. So there's a command here called serve. We call it daemon, but it's serve. And serve serves every one of these other endpoints with exactly the same options as the command line options. So you can stand up a server and write an application against this thing with really fast, really good, deep, accurate data for the history of accounts. Smart contract developers could use this. So, they probably use the graph today, or they use their own indexing tools or whatever. My guess is their own indexing tools are very specific to their own contract, so as soon as they go to another one, they have to rewrite that code. The graph only looks at events, as far as I know, unless it might look at traces at this point. Do you know? Just event.
But it doesn't simulate, so it needs some parts.
Yeah. So, and very important to me, why do I have to pay for access to the data through buying coins? That just makes no sense whatsoever. We should just fix the node software so that it actually indexes, because that's what the community needs, and the community is constantly building it. And companies are coming along and saying, hey, I'll do the indexing for you, pay me $300 a month. It's great, fine. I can write software that literally changes the node software so the node does it automatically without having to pay anyone to do anything. And I think we should do that. So I'm not going to, I have 10 minutes left, so we can do anything you want. I have a couple other examples, but I'm happy to ask any, or answer. I could ask some questions as well. I would absolutely love for you guys to tell me, are you running TrueBlocks? Any of you? How's it, and it's working well for you? What do you do with it? Like?
I started 2 weeks ago.
Oh, okay. So you haven't gotten through the 2-week period. At the end of 3, most people quit using it because it doesn't really work all that well. But
What does the API look like? It's a REST API, GraphQL, or how do you get the data out of it? Is it processed by front-end, or do you need another backend to actually use that?
so in order to start the API, you type Shifra serve. So that started the API, and then I can just hit it with curl or something. Hold on. So that's getting data from curl after having started the server, and the API is identical it's identical in every way to the Shifra command line tools. It has exactly the same options, and you basically use it exactly the same. And we built this part because we want to build little applications. So maybe I want to build an application that looks at my Gitcoin grant behavior or something and compares it with Rocky, because I do that all the time, to my detriment. Any other questions? Yeah.
When are you going to have it in the node then?
Excuse me?
When are you going to have it in the node? In red, let's say.
I'm sorry, any other questions? I'm going to have it, I don't care if TrueBlocks is in the node. I don't care about that. I care that indexing is in the node. And I think that people will come to understand, especially as we go to 40 layer 2s, that if the only way for people to get accurate histories is through an API provider who's charging $250 for layer 2 number 1, layer 2 number 2, every one I want to use, people will understand eventually that this is a problem that can be solved in the node software. And it should be solved in node software. So I kind of don't, I've beat my head against the wall for 4 years. This should be in the node, this should be in the node. And I know it should be in the node. When is it in the node? When people understand that it needs to be in the node and demand that it gets put in the node. I'm not even gonna probably fight that battle, other than to stand up here and say it should be. Do you see what I'm saying? It's too hard. That's too hard a problem. I can't do that.
Because the node developers are not interested or something.
Node developers are what?
The node developers, client developers, they're not interested?
They are busy enough, kind of. They have enough on their plate, and there are solutions out there that, take the burden off of them. People don't demand it from them. People accept that accounting software, which is using all these APIs and coming up short, they accept that it's okay for the accounting software not to reconcile. So I think in the end, we're going to figure out that indexing is going to be, and not only indexing, but indexing that actually works and produces reconcilable state off-chain, and is fast, it's not costly. I think we're going to figure it out, and if we don't figure it out, we're just building something that I don't even give a shit about, to be perfectly honest. It's just not interesting. It's just the same old thing. And I can't, it's like, I can't solve that problem. I can just show people that it's solvable, right? Any other questions? We have like 5 minutes. Does anybody want to ask anything? Yeah? Oh, sorry.
Given a smart contract address, can you query which transaction it was deployed?
Yeah, absolutely. Because we see every appearance. So deployment, it comes in the receipts contract address thing, so we'll pick that off naturally.
Even if it's internal transaction?
Yeah, because we dig into each little piece of the bytes, and down in the traces, there's a trace response, I think, or reply or something, and it's in there. So
something that I can find in the API.
So tell me, well, I'll just pick a smart contract, like let's say the Gitcoin. So we've also been doing something that I probably shouldn't tell people, but I'm going to. Everybody goes on Twitter and says, give me your address and I'll give you some tokens. Every single time that people have done that for the last 7 years, I've copied all of those addresses along with their Twitter handles, and I put them in a database that's called names. So we list 13,000 names where you guys have doxed yourself. And I don't apologize for it. It's not my fault. I can say Gitcoin core. This one. So this was the Gitcoin address. This is a smart contract. I'm going to say Gitcoin list. And it's going to go and get, this is Sepolia. Let me go on to mainnet, hold on. So I'm on a different machine now. So I can say Shifra list. This is Gitcoin on mainnet, okay? So that's every appearance. And the first appearance is where it was deployed, okay? Huh? Yeah, the block number and the transaction ID. Yeah, that's right. That's what an appearance is. It's an address and where it appeared, so we can find it. We don't have to scan the chain to figure out where it is. And then I can say export. I can say format JSON, and I can say last block, and take this block +1. And that's the deployment there. That's the deployment of Gitcoin. So it kind of just naturally falls out because we find we find as many appearances as we can. Yep. And this is really interesting for like Uniswap as well too, because we can see the factory creating smart contracts. Yeah. Anyone else have any questions? Any comment? Can you guys give me some feedback on TrueBlocks? Should I continue working on this project, or can you help me get some funding, guys? Who has funding? Who has funding? Raise your hand if you have funding. Hello? 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 Hello, hello, hello. All right, great. So I'll just continue this project on my own funding. That's a great idea, yeah. I'm going to just turn this into a business if you guys don't help me out. Retro, yeah. Vote for me if you're a voter on optimism. Vote for my project, because I'm really all about sort of, we can do this as a community, because if we don't do it as a community, somebody's going to capture this thing. Somebody's going to take it away from us. They're going to have it. We're not going to have node software that even comes close to doing this in the future if we don't get it to do it now, because in the future, the big data providers are going to move the needle of where the node software behaves to the point where it can't even do what I'm talking about, because they throw away the ability to run node software on small machines, because it's not in there. They don't need that, so they just toss that. It's not a purposeful act. It's just what happens with software is it gets pressure from the place that people are pushing on it. And if we're building APIs, Web 2 APIs, and all the node software is behind a Web 2 API, all the API providers are deciding what happens with the node software. So I'm saying, let's not let that happen. Let's change that and make it happen a way that works for us. So thanks for coming. I really appreciate it. We have a question? Absolutely, yeah, certainly. Yeah. Now, what they did though is they went into the internals of Aragon. And I kind of chose not to do that because I wanted to stay so I could go against any node software. So, I don't know that their indexing is quite as thorough either. They're more focused on the indexing you would need for a blockchain explorer, which is maybe not the same thing as for reconciled state histories. But yeah, no, I'm friends with them, actually. They're talking later today, actually.
Is it also the roadmap to support kind of webhooks or whatever? So when you see that the transaction is happening, that is all external stories and things?
Yeah, absolutely. We have a feature called monitoring, and you can give it a list of addresses. In fact, we gave all 2,000 Gitcoin addresses to a monitor, and it was just watching all 2,000 every 12 seconds whenever a donation came in. I can actually show you that real quick. I have a minute, I think. So if I do tokenomics, So we wrote this thing that was monitoring all the Gitcoin addresses, sorry, and just updating a database and then generating a lot of different pieces of data. This is about 2,000 addresses that TrueBlocks was monitoring on my laptop, generating data for this dashboard. And it's interesting because when you have, even with 2,000 addresses, there's a block every 12 seconds, and maybe 6 of them have a transaction. So it's a really light thing, so it doesn't take up a lot of resources. This worked for a while, and then we kind of stopped because it's a little bit of a pain in the ass. But yeah, no, you can do exactly that. Yeah. It's not full featured yet, that feature, but you're welcome to help fund us to do that.
And the last one, do you currently only have, let's put it another way, token balances, or could I also get information about all the contract interactions, etc.?
All the contract interactions. We call it articulation. So we get this ugly byte data. We can pull the API from some source, Etherscan, which is really the only source. And then with the API and the byte data, we decode that transaction. And we can give it back to you as what we call an articulated log or something, or an articulated trace. And it shows you in words what everything was. So it's very nice, actually. I think I answered exactly what you asked in a way that didn't maybe match up with your question, but yes.
Yes, you get the
We don't use webhooks or anything. We just kind of.
Okay, but you get the events out of the transaction, and then it gets decoded.
We decode it, and it comes back as English, and you can understand it really well, and you can pop it into your database and do whatever you want with it. And you could run it as a monitor, so you constantly have a fresh update of your state of your entire system, because it's not just logs, it's traces as well. So you get even more than just watching logs, which I think is something that you probably aren't getting elsewhere, most likely. Maybe. Or you wrote it yourself.
Sorry?
Or you wrote it yourself.
My first one I wrote myself, but Tenderly as is Web3.
Tenderly,
Where
yeah.
you get all
Yeah.
that stuff to you, and they
Yeah.
trigger the script on every block.
Yeah, we're going to start competing with Tenderly next year. Oh, I'm done. I'm sorry. Yeah, well, thank you so much for coming. I really appreciate it. Please communicate with me in Discord. I'm very helpful, and I'm looking for feedback, so thank you.
kurz. Ah, okay, genau. Also es dauert wirklich so ein, zwei
Yeah. Hi, everyone. Good morning. Happy Monday. We have some technical issues, as you can see. But I thought like we can maybe just start already in case the presentation pops up at some point. And if it doesn't, we're going to improvise. My name is Zuza. I'm a DevRel at Snapshot. And today I wanted to talk to you about governance. And even though I'm a DevRel, this won't be a strictly technical talk. It's mainly about talking about the challenges that we face today in the decentralized governance, and also realizing what is actually possible with Snapshot as the tool that many people are using. And now question, like, do you know what Snapshot is? Yes? Good, perfect. No? No? So Snapshot, ooh, something, no. Okay, Snapshot is a voting platform for different projects and enables anyone who owns an address, a crypto address, to take part in governance, be it crypto projects or also a group of friends that want to take decisions together. And now, who of you have ever taken part in decentralized governance? Okay, cool. So who of you have participated in a discussion when there's something going on in your organization and like people were chatting on what we can change, what we can suggest? Nice, okay. And who of you have created a proposal? Yes, good. And who has voted on Snapshot? All right. Who has delegated their voting power? Who's a delegatee? Yes, okay, amazing. So we all know what Snapshot is. So as we don't have the screen right now, I would like to invite you to turn to your partners, your neighbors, and have a chat about what are the biggest challenges when it comes to governance these days. Be it ideation, the discussion, the voting part, the delegation, or execution. So let's take a couple of minutes to just have a chat. We can also like find a throuple together, or 4 people together, and in a couple of minutes we can discuss it all together.
Can we please put on continuing soon? The continuing soon frame, and please switch off the sound.
Can you maybe tell me which were the challenges that you were talking about first as the issues without the solution? Because I guess you also talked about the solution already. Guys want to go?
Talking about participation in DAO governance.
Mm-hmm. And what about the participation?
Not a lot of participation. This is the problem.
Okay, so low participation in governance. And that is in terms of like maintaining the members over time, or low participation in general, and the difficulty to motivate the members to vote at all.
Yeah, I think over time, and not just voting, also participating and
Okay.
coming up with proposals, commenting.
Okay, so we have like the engagement and discussions and ideation, suggesting something new, and then also voting. Okay, cool. And what did you talk about? Your group?
We were talking about missing incentives to participate.
Okay.
Because you only have kind of cost in terms of transaction fees or just following time to follow discussions and understand them. You don't necessarily have a return for yourself.
Mm-hmm.
Maybe even just like even holding the governance token is maybe you could rather convert it to ETH and stake it, and that would be financially the better option.
Okay. Cool. So we both, like you both are talking about really participation and engaging the members and like maintaining the participation within the voting process. Luckily, Snapshot is free. So no transaction fees, which is actually one of the good incentives for the users, because there is nothing malicious that can happen. They're just signing a message. They're not paying anything. What we can do, we can chat about it later when it comes to different solutions that are possible when it comes to the low participation. But actually, there are also other problems around governance that we've seen, starting, for example, with spam, which can be also quite a big discouragement for the members, because whenever they go onto your space profile on Snapshot, they only see some random proposals that just have actually also scam links inside. So users are being discouraged from even reading the proposals. Voter apathy, not really interested in voting. We also have the whales, who are also discouraging the community to take part in the vote if the community members know that there is someone who owns majority of the token. They don't even want to vote, because what is the point if that one person can come in and just overrule the entire proposal? Then we also have staking. While, as you said, maybe it actually makes more sense to stake the tokens I hold. There are also solutions on Snapshot that allow you to counteract that, because we can check how many tokens the user have staked and then calculate their voting power based on that. So actually you can have both. Then we also have delegation. Who to delegate to, how can I do it, how the voting will go, what if I actually want to take part in a specific proposal. We also have bots that are basically overruling the proposal. So basically whales create hundreds or thousands of addresses and split their tokens, and then they automate the entire process. And lastly, exactly what we talked about, the low participation. So then, when it comes to the governance customizations on Snapshot, there are several ways you can actually address all of those problems. And each space can basically create their own very unique setup depending on their needs. And the 3 building blocks that I wanted to show you are voting strategies, validation strategies, and voting types. Where voting strategy is basically a tool that tells you how much voting power do you have, and also enables you to actually use the delegated tokens from another user for the proposals. In technical terms, it's just a JavaScript function that takes an address and returns a number. Then we have validation strategies, which basically check if a user is eligible to either create a proposal or cast a vote. And this is actually really useful because you may, for example, limit the proposal creators to specific users, to specific members that have a specific experience or have a specific role in your DAO or have a specific amount of tokens or have been a member of your DAO for, I don't know, at least 6 months. Then we have the voting types. Basically, voting types are the voting systems that you see on different proposals, which allow you to say that I only want to have a question in the proposal, and then I vote yes, no, or abstain. The other solution would be, for example, multiple choice voting, where you can provide different options the user are voting for. We also have quadratic voting, weighted voting, plenty of those. And the voting types are actually defining how the final result of the proposal is calculated. What we require at this moment is a combination of at least one voting strategy and proposal validation strategy due to recent scam and spam attacks, which went from Twitter or X to Snapshot, where there are plenty of new proposals with a lot of malicious, scammy links that were redirecting users to other domains and also inviting them to sign a transaction. So, when it comes to the most common solutions, you probably know them yourself. The crown jewel is our ERC20 balance off, which is a voting strategy that allows you just to provide the token address, and it returns the amount of tokens that you hold in your wallet, and this is then your voting power. We also have whitelist, which is taking as an input a list of addresses that will all have one voting power. You can check for ETH balance. You can also use NFTs to vote, and so on. And as you can see, they are quite popular, as, for example, ERC20 is in over 10,000 spaces on Snapshot. However, what we want to talk about are actually specific use cases. And we'll start from the Sybil resistance, so basically the way to avoid scams, the spam, and also make sure that your voters are not bots, but they are actually genuine humans. And what you can do for that is to use validation strategies. And what we provide on Snapshot at this moment are mainly two strategies. One is the basic one, where what you can do, you can take the set of the voting strategies that you're using to calculate the voting power, and just say the minimum balance for this user to vote or create proposals has to be 20. What you can also do with that is to select the custom selection of the voting strategies different than you use for the voting power, and create the setup for the validation separately. Then what we also have the Gitcoin passport validation, which is now being updated to the Gitcoin score validation, which is actually the stronger proof of Sybil resistance, where you check for the score of each user that you can set at whatever level you wish to define. And the validation strategies, as I said, can be used for proposal validation and the voting. Then we have voting strategies, and what we have is a whitelist, which is the easiest way to define who can vote, and you basically have a selection of your members that provide your addresses, and you set them up in the strategy. The other option is a membership, which is based on an NFT. If a user holds specific NFT, they will receive one voting power. And then when it comes to managing the different responsibilities in your space, you can also use space roles in your space settings and define admins who will be able to change the settings of your space, moderators who are responsible for managing the proposals and, for example, flagging a proposal if they see that it has malicious content. And then you also have authors that are the users that are eligible to create the proposals without meeting any specific requirements. You just provide their address. What is also useful when it comes to the Sybil resistance and like monitoring what is going on, you can use webhooks that we provide that you can get for the new proposals and for the ended proposals. So if you want to keep an eye on what's going on in your DAO, it's actually really good to set it up. The other solution would be also to set a Discord bot, which will notify you in the channel, like, hey, new proposal, check it out. And then you can ask also your moderators to have a look to make sure that the space is clean of scam. Also, if you have any questions, you can like raise your hand, let me know. Then, talking about the whales and the voter apathy, the discouragement because there's someone who can just overrule the entire proposal, we also have ways to act against that. First off is the quadratic voting, which is one of the voting types that then is calculating the result of the proposal. It is not, however, exactly the same as the Gitcoin quadratic funding. It's a bit more sophisticated in a way where it comes to the democratic process of voting. And if you want to have a look at it, that's a QR code to our documentation with a bit longer explanation showing you the real example of like various users, different options, the tokens they hold, so you can follow the process throughout. And what matters here is that we really care for the amount of users that are taking part in the voting rather than their holdings. And as I said before, whales can also do a trick of creating hundreds or thousands of accounts and then setting up a bot that will basically take their entire holdings and vote as 1,000 different addresses. Quadratic voting, perfect, they got what they wanted. So in order to make sure that this is not possible, you should be able to set it up with the voting validation that will check for the Sybil attacks and make sure that the addresses are not the bots, but actually they are most probably human. The other thing, we also have our voting strategies, where there is a specific anti-whale strategy, again, explained in the documentation, a bit more difficult setup, but it allows you to set specific threshold above which the voting power will be decreased and below which the voting power will have more significance in the voting process. There is also a strategy called balance off with thresholds, which basically mean that you can set buckets. And if someone holds up to 5 tokens, their voting power will be 0. From 5 to 10, their voting power will be 1. And from 10 to infinity, their voting power will be 2. So even if the whales are holding large amounts of token, their voting power will be really, really small. And then we also have voting privacy with shielded voting. This is one of the options that you can select in the space settings. I'll talk about it in a second. But the idea is that basically, while the proposal is going on, no one can see what is the current result and who voted what. The votes are private until the proposal has ended, and then anyone can release it. So basically, when a whale comes to a proposal, they don't really know if their vote will really change the outcome. So not fully secure when it comes to anti-whale strategies, but can also be useful in this case.
Shielded voting works with, for example, kind of validation strategies?
As well, yes. It's a separate kind of module. Shielded voting, all it's doing is encrypting the votes on the IPFS, so no one knows what the user has voted, what is the current result. And at the same time, this address can be checked if they have enough of voting power. So if you want to go into the details, if you know that the validation is actually set at, I don't know, like you need to hold 50 tokens, and if you follow these addresses that voted, you can figure that they are eligible. But they can work all together, no problem. So, shielded voting, what I just mentioned, hide the voting results while the proposal is live, and then release it after the proposal has ended. How to do it? You go to the space settings, voting section, then select privacy, and then you can select the option with shutter, which will then lead to a proposal where you only see the addresses or the ENS domains, but you don't see the results at all. Then, what I also wanted to show you is something we released recently, which is a space handbook, which is basically like a Bible of how to use Snapshot for different use cases, and we're still building it up and developing it. As you can see, what we have here as well is, for example, liquidity and staking pools. So what we have are the voting strategies where you can provide the addresses of the vested stake tokens and basically read the amount that user really owns. They don't own them at, in a specific moment. They have them somewhere, but they can still use it to vote. So maybe actually the real problem is that the members don't know about it. They don't know it's possible. So a key issue is actually communication and letting your members know what is possible and how their votes can be actually counted. If there are any other use cases, if your organizations have any other needs, it is also possible to create your own solution, be it voting strategy or a validation strategy. And here you have a link to the documentation. I'll share the slides in a second. And currently we have over 450 different voting strategies on Snapshot, which basically allows you to do anything when it comes to the voting power. And the tool is very flexible. Same goes for the validation. If you have a very specific use case, which is not covered by the basic validation, which takes into account the voting strategies, or is not covered by the Gitcoin passport, it's also possible to create that. So from the slides you have the links here. Also, the QR code leads you to the slides if you want to have a look at that. And do you have any questions, or do you have any other ideas or solutions to the problems you defined before that you haven't seen covered here? There we have a mic if you wanna. We didn't take it before.
Okay. So regarding spam, you mentioned validation, and then for us, it still doesn't solve it. We don't want to have just a specific set of users being able to set proposals, and token amount threshold is not solving it either, because if you want to have good spam protection, you have to set it very high. We don't want to do that, and even that allows spammers to just buy enough tokens and post anyway. And then another solution that we thought of is essentially having 2 stages for a proposal. One that is kind of hidden from the main space, but still allows to gather kind of a minimum amount of participation or support. And then if a minimum amount of support is achieved, then it becomes like a fully fledged proposals and goes into the main space with regular voting.
Okay, so you do it on a kind of like a subspace or a separate space to kind of have a temperature check?
We don't do it at the moment. It's something that we would wish to have.
Okay. So this might be actually possible in the future. Currently, what you can do is to have subspaces linked to your main space. And one space might be used for the temperature check, open validation. Anyone can create it. So you may experience a lot of spam, but then actually you can take those proposals that had a lot of interest and duplicate them. There is a function where you can just duplicate it to the main space, which is the actual voting.
Actually, we are using subspaces for something else, and I don't think it will solve the spam problem because everything from the subspace is showing on the main space. So you still get the spam problem.
One thing that you can do, we had this problem with Lido, because they are basically the kings and queens of spam proposals, like 10, 20, 30, 100 daily. And what we did right now is that one address can only create, I think, can have 10 active proposals at a time, so at least one address cannot create that many. A space can only have also a limited amount of active proposals at a time. So maybe what we can do specifically for you, is to limit the number of active proposals for space directly in the code base. So then you know that you only want to have a specific number only when they pass. Then someone else will be able to create a new one. One thing that you can do is to basically, what you can do when you go to your space settings is when you click on the filter there, you can display all the proposals, because by default we are not showing the proposals we flagged, and we have an automated and a manual system for doing that. What you can see here is basically when the proposal is flagged, you only see the warning that it may contain something malicious or spam, and basically only if you click show, you will go and see the content. How to do it, you can go to a proposal and then report it here. And soon we will also have a feature that will allow the admins of the space to flag directly. So that might be quicker, and then basically they will not pop up on the main space. And if you set a webhook system or a Discord and you get notifications and have multiple users that can basically flag the proposals, then it might be easier. But the problem is, if you want to allow everyone to, to propose, it's not always that easy to avoid spam.
Yeah. Cool,
Would that be any helpful?
Not sure, because we don't have admins on our space. But
okay. Is there a reason for that?
Because they can change space settings, and we have a OSNAP module installed, so it actually uses the space settings for execution validation, and we don't want people to be able to change the space settings.
Okay, got it. Then maybe we can consider another role, or allowing the moderators to flag proposals, so that they won't have access to editing the space settings, but they can actually just click to flag something, and you can whitelist those. So maybe that's also another option.
Cool,
Good.
Thank you.
Yep.
Just to add to that thread, I guess, have you guys thought about allowing a safe smart account or multi-sig to actually be the administrator?
It's already possible.
It's already possible?
Yes. Yeah. It's a bit more complex, and safe UI is not very intuitive when it comes to that, but we're also working on a solution that should enable easier management.
This is actually already the case for us, because the safe that is the owner of the ENS domain that is the space itself.
Yeah, thank you. I had another question about Snapshot to understand a bit how it works. So as I understand, it's all off-chain, right? You just read the blockchain data to get the balances. And I was thinking about your ERC20 balance off voting strategy. So as I understand it's not possible for you to implement any token locking. So is it possible that somebody maybe has, let's say, 10 accounts, and they have some amount of tokens, they vote from one account and then transfer them to the second account, they vote from the second account, and so on. So is it kind of a possible situation? Is it possible to mitigate this somehow? And have you thought about this?
What scenario are you talking about? Like,
so,
it's the whale like splitting their...
No, maybe it's not the whale. Maybe I'm just a user, I have 1,000 tokens, but I want to vote as if I have 10,000 tokens to inflate my voting power. So I just create 10 different accounts. I vote from the first account, I transfer them to the second, vote from the second, transfer them to the third, and so on. So I do this 10 times. But if I want, I can do this 100 times, I can do this 1,000 times, and there will be 1,000 different accounts voting with 10 tokens each, maybe. But yeah, in total, it will be quite a lot of voting power.
So this is actually not possible because we checked the balance of the tokens at the snapshot of the proposal creation.
Okay.
So basically, when you have the chain, the proposal was created here. Whatever happened afterwards, whether it's delegation, whether it's transfers, whether it's staking, whatever, is not taken into account. We only look at this specific point in time. That's why snapshot.
Okay. Yeah, makes sense. Thank you.
No worries.
If that's the case, don't you get the problem that at the snapshot I may have some tokens, I use them to vote on a proposal, and then I kind of sell away my liability by moving the token somewhere else, since they're not locked in any way, right? They're just locked to the specific state at that moment.
That's completely fine. We don't want to interfere with your holdings and kind of judge what you're doing with it once you voted. The thing is that you should have the tokens before the proposal has been really posted. So you can't see the proposal and get the tokens. You just you hold the tokens first, and at the moment the proposal is created, we don't look at whatever else has happened later. So if you have the tokens, you vote and then you sell them. That's good for you if you made some profit. So
yeah, I was just thinking if that could introduce some misalignment, let's say, between the incentives of maximizing the token value, at that moment.
This is kind of out of our reach because we're just purely governance, not really DeFi. So.
Do you have any data on how many DAOs are using certain strategies, that kind of thing, like percentages? How many are just using the ERC20? How many are using a override? Is there anything is there a blog post I can look at?
Yeah, actually, let me have a look if we have updated data. We have a dashboard on Dune, and there are a couple of other dashboards. Maybe I can just add them to the slides.
What's the Dune ID or user ID?
Dune is basically Snapshot Labs. That's our profile. And then also, if you search for Snapshot, that was one of the projects in the Aragon hackathon some time ago, and we had a couple of really good submissions with in-depth analysis of the usage of the voting strategies, the biggest DAOs, what's their setup, what's their participation, what's their number of their proposals, and so on. So a lot of good stuff to have a look at it. And as data is off-chain, it's not always up to date, but we're now trying to figure out a way with Dune to make sure that we update it on a regular basis.
And another question, is there any talk about so most people use the Governor Bravo contract, right? But the token contracts themselves have different events that are emitted when delegations take place, and there's no standard. Is there any talk about the standard events? And the problem there is, so if you're building a tool to index, delegations, those kind of things, voting power changes, it's really difficult because you almost have to treat each DAO, each token as its own thing. It's hard to build a tool at scale. Is there any talk about standardizing token events specifically? That's kind of niche.
So not at the moment. What is currently possible with delegation is to delegate through Snapshot. We have our own delegate registry contract, and also then you can set up a delegation with the contract that you have as your own organization. However, we are also working on Snapshot X, which is the on-chain voting solution, which will actually be reading the voting power through the indexer, which we're also building ourselves. And then it's highly modular, and basically you can also fork the repository. It's called, let me have a look. If we have it somewhere on the docs. If I can see it somewhere. There you go. Checkpoint, and you can basically fork the repo and either load it in basically import it in your own project or build on top of that, because this is also an open source tool, which we built first for Starknet, and then we are currently adapting it to be EVM compatible. So you can have a play with that.
Okay, thank you.
mic. The root of the mic is, I think, more optimal.
I would have one more question about like the general architecture. So as far as I understand, the voting happens off-chain, and so also the computation of the outcome happens off-chain?
Yes.
And could you say a bit about the architecture and how it's ensured that it's trustless or decentralized? Like in particular that no votes are left out and not considered, and the correct snapshot balances are considered?
Yeah, sure. So basically, as you said, the off-chain architecture is not on-chain, exactly. However, our infrastructure was built with the idea that basically it's censorship resistant. It's censorship resistant. Basically, anyone can have a look at what happened throughout the process. And what is going on is that currently you have the snapshot UI on the left side. When user casts a vote, the data with their signature goes to Snapshot sequencer, which is kind of like the central hub of everything that is going on. And Snapshot sequencer is verifying the signature, sending the address to our Score API. Score API is responsible for calculation of the voting power or the eligibility to vote. Basically, it can communicate with anything like a node, a subgraph, or an API, which can be unique to a specific DAO. Once we receive the data and the signature is verified, basically, sequencer has its own private key. Once it's signed with a private key, we store it on IPFS, we store it on MySQL, and what we store there is the entire history of Snapshot. So anyone can actually fork our infrastructure and replay every single action taken from the very beginning of Snapshot. Every single new space, settings update, new proposal, a vote, delegation, and so on and so forth. You can also read the data from the Hub API directly. And basically, like, there is an entire article about that. So I would really recommend to go through that to understand like more details. But the goal is to decentralize it fully with Snapshot X, because we know that off-chain is not fully decentralized, it's not fully trustless. So we really want to make sure that anyone can know that this is basically out of our hands and it's all basically code.
Yeah, thanks. That explained it well.
Okay. Okay, last question, I guess, and we have a break.
Mine is a quick one. Just any news regarding Snapshot X and its release date, tentative?
Never ask about the release date.
I know.
It's coming. It's coming. It's actually already audited. If you go to our repository, if you go to Snapshot Labs, let me just do this. And you find the SX repos. Let me see if we publish it. We have SX Darknet, we have our UI, we have the APIs that will be available for everyone. Also, SX EVM, which is currently, so SX EVM has undergone an audit. So code freeze, all good. And now we are also building the solution for Starknet to have like really fast and cheap transaction fees on layer 2s. So it's coming soon.
Do you know if the SDK is final?
The SDK, we're still developing it. So it's kind of like, it's final for SXEVM, but we're gonna probably still change it due to the Starknet implementation. Because if you use the Snapshot.js, SXJS is much more complicated to set up, depending on which, basically which network, which layer you're using. And we also don't provide currently the SXJS documentation, because simply it will still evolve. That's why that was the talk on Snapshot off-chain, not yet on the on-chain, but the next talk should be probably on the on-chain voting.
Okay. Thank you.
Thank Thank you. All right. That's it. Thanks so much for joining. Also, if you have any questions, like, you can ping me, you can find me, you can join our Discord. And always happy to hear your feedback and like suggestions for whatever your needs are. Thank you.
So, hello everybody. I'm running a workshop today about how to build confidential EVM dApp with smart privacy. So, I'm Harry. I'm a technical product manager at the Oasis protocol. I'm handling the Sapphire EVM chain and the Oasis privacy layer. So, the workshop slides are available. If you want to get your laptops out or scan or whatever, you can run through them with me. There's going to be lots of code examples. And lots of really, really useful stuff if you do want to try and build some stuff. So roughly, we're going to go through smart privacy, confidential EVM, how's it different, getting started with building apps, then some examples and some cool stuff, I hope. So what is smart privacy? I think this is a good place to start, which, how many of you are like privacy maximalists? So you're all privacy, no transparency, right? But what about transparency? Because everything on EVM is transparent, right? But realistically, like the rest of the world exists in between where we need privacy and we need transparency. So think of like if you're sending an envelope to somebody, you want the inside of the envelope to be private and the outside to be transparent. And at the moment on EVM, that's just not possible. So there's a lot of sort of different use cases for this. So like if you look at the use case of ZK, you're providing proofs that you know are secret, or you're having transparency but only within select groups, or conditional access control. So you want to be able to gain access to something but only if you know the secret or someone's given you access. So fundamentally, smart privacy is conditionally controlled by the smart contract. So rather than the protocol being all private, the contract gets to decide what is and what isn't. And so really like confidential EVM enables all of this. So if we look at ZK, which this isn't ZK, so with the ZK EVM, you can do roll-ups of lots of transactions. You can provide proofs that something, like with Zcash, you can provide proof that you own a coin. But the contracts can't have their own secrets. So if you can keep your stuff secret, but it's not sort of autonomous. And with MPC, if you look at a lot of the bridges, so if they're doing cross-chain stuff, the MPC protocol will keep the secrets itself so that they don't get leaked. But you've got lots of network back and forth between the MPC members, which means that it's slow in practice, right? So realistically, we're using a compromise, which is inside the trusted execution environment, powered by SGX. It allows us to run contracts at almost full speed compared to the regular EVM, but the contracts can have their own secrets, which is what this is all about. So what is the different components? Well, fundamentally, we have the private computation. That means the node operator can't see anything that's happening inside the contracts as they're being executed. We've got private storage, so the contracts can store stuff, retrieve stuff. Again, the node executor can't see what's being retrieved or what's being stored. We have a built-in VRF, so rather than using an external service, you can, from a contract, say, hey, give me some entropy, I need 32 bytes, 100 bytes, whatever, and that happens instantly. And then end-to-end encryption, so the contracts can communicate with users in their browsers without the relay nodes seeing what the content is, and you can securely submit secrets to the contract without anybody seeing. So we've got a Sapphire EVM, which is our private blockchain. It's a paratime which is secured by the Oasis network consensus, and everything inside the EVM is private. But we're going to cover some examples that show the different use cases of confidential EVM. And that's really like what to be aware of in terms of edge cases, because there are a few edge cases where it doesn't act as you'd expect it to if you're used to normal EVM. So it's 99% compatible, but you're doing privacy. So you need to be aware that EVM expects everything to be transparent. And if you want to get started, there's a bunch of links here, so the documentation, the testnet faucet, the Explorer, and a couple of demo projects on GitHub if you want to check these out. But yeah, with the testnet, you can add this to your MetaMask, and it's in the documentation there. So because it's a different EVM, and there are differences between transparent EVM and Sapphire, if you're developing with Hardhat, for example, or Foundry, you won't be able to run the full set of functionality that you'd expect to. So if you want to use the VRF, for example, if you run it in Hardhat, you won't get random data. So in order to develop on Sapphire, you're going to need to use the Sapphire dev Docker container, which will spin up a local node of the Sapphire local net on your machine. Alternatively, you can develop against testnet, and you can use the faucet to get tokens for that. So what are the differences between confidential EVM and transparent EVM? So we've got call data encryption. So that means when you submit a transaction on chain, you can encrypt the call data, and it will still be included in the transactions that are visible on the block explorer. So you'll see how many transactions have been made, the size of the call data, who it was from, the contract that it was to, the amount of gas that it cost, but you won't see the call data itself. And we've got encrypted storage. So again, the node operators will be able to see that you're storing things, see that you're retrieving things, but they won't know what the content is. And there's also a question about, can you trust the message sender parameter? So a very quick overview of this, we've got the key manager that controls access to the storage. So the confidential contract that's executing inside the trusted enclave requests a key from the key manager to be able to retrieve a single piece of storage. So unlike other networks, if there was a breach of the compute node, the attacker wouldn't be able to get the secrets for all of the storage. They'd only be able to see the specific piece of information that were accessed while it was happening. So we've set up in this way as a bit more reliable than others. Right, so let's do some examples. So I'm going to start off with a private token, which is the most straightforward use case of I want private money on my private chain. It should be straightforward. So you say I've got my transfer command, and I subtract the amount from the balance, add it to the other balance. Of course, we're not verifying what the transfer is. It's just doing the transfer itself. And you'd think there aren't any problems with this. It should be private, right? Because it's running in a confidential EVM, it's got confidential storage. But the problem is that, the compute nodes will see the I/O patterns. So as I said before, you've got encrypted storage, but you still see the access pattern. So if you subtract from my balance and add to somebody else's balance, that's going to reveal the people that were involved in a transaction. So for some cases, that's not a problem. But if you want real privacy, you have to consider this as well. Because a lot of the attacks you get against privacy systems is essentially like tracing through a graph. So if they can see this person transferred to that person, to that person, to that person, even though the balances are hidden, you'll be able to infer from that graph of transfers, who transferred to who, and infer what amount as well. So there's a really cool utility called Hardhat Tracer, which lets you see the sload and store commands. So if you're worried about this aspect of the privacy of your contract, of will this reveal information, you can use this to take out specifically the sloads and the stores and see what's going on. And then that lets you develop some patterns to obfuscate that. So for example, if I wanted to switch these around, I say randomly select subtract first, then add afterwards, or add first, then subtract afterwards, then just looking at the I/O patterns, you won't be able to see, well, was it a transfer from this person to that person, or that person to that person, and vice versa. Or you could put in dummy accounts. So if you wanted to obfuscate in a similar way to Monero does with the ring signature mix-ins, you can say, of all of these accounts, I'm going to load all of their balances. I'm going to modify one with my, with the payment that I'm making, and then just write the same value back to all of the others. So if someone's doing analysis, they'll see, oh, there were 10 different storage stores, and I don't know which one of these are real. But in most cases, it doesn't really matter. So if you're not looking at sort of really strong privacy guarantees, then it's, there's lots of other things you can do that aren't so serious. But the second part is side channels. So because with every transaction, you can see the from, the to, the size of the call data, the amount of gas it takes. This can lead to sort of unexpected things where, the amount of gas that's used will reveal which path within the code was taken. So this can have unexpected consequences. So in this example, I'm checking, hey, does this person have an allowance big enough for the transfer to happen before it's verifying that whoever's creating whoever's performing the transaction has that amount allowed. So, yeah, I've mentioned this already. With a gas channel being public, you can start to sort of perform tests. So if the balance check is before any of the authentication, I can say, is this balance 10 ETH? And it will give one gas rating. And then I say, is it 0.1 ETH? And it will give me a different gas usage. So with this, I can perform a binary search and go through and find what the specific balance is. So in terms of like authentication and not revealing information about or the balance, you need to move authentication up to the top and make sure that no extra information is revealed through the gas side channel. So the second problem is view calls. So on Ethereum, we've got the ETH call, RPC, which simulates the transaction. And again, this is a problem, because on confidential EVM, you don't want people to impersonate you. But on regular EVM, you can simulate a call to any contract from any person with any gas amount, whatever, and it'll let you do this. So if I wanted to check someone's balance, in confidential EVM, this would be bad, because you can get everyone's balance, and of course you want the balance to be private. So we can check my balance. So if I want to view my own balance and not be able to see anybody else's balance, then you can use the message.sender parameter. But the problem there is, how do you know that the message sender is, if it's a view call, how do you know that they are who they say they are? So this is a problem that we've had to overcome by signing view calls. So you can have anonymous view calls where the message.sender parameter will be overridden to 0. So if you don't specifically sign your view calls, then the chain doesn't know who you are when you're performing a query. And this is all automatically wrapped with our wrapper with the Sapphire Paratime package. So if you're writing a client or a dApp, whatever, and you want to be able to use the message.sender parameter, you're going to have to sign your view calls. And essentially, you just wrap the provider that's provided by MetaMask or Hardhat. If you're using Hardhat, if you add the Sapphire Hardhat package in and put it in your hardhat.config, then it will automatically do that for you. But there's one problem, which is with signed view queries. If you're a user and you're using MetaMask, then every time you perform a view query, it's going to pop up and go, oh, hey, please sign this transaction, right? It's not a transaction, it's just you need to authenticate your query so that the contract knows who you are. Otherwise, it doesn't know who you are because you're anonymous. So with this, so with this, you can then verify, you can then use this to say, oh, okay, am I allowed to see someone's balance if I have an allowance with them? So in terms of rethinking how you deal with tokens, token transfers, and the standard sort of ERC20 stuff, you can port it over, but it's not like directly applicable because of all these sort of side channels being able to see everyone's balances. If you're doing privacy, you're going to have to modify it in a way that means that even with allowances, you're only revealing information that they know. So if I give you an allowance of 1 ether, for example, but I've got a balance of 2 ether, you don't want to reveal that I've got 2 ether when they can only spend 1. So there's a couple of other approaches in terms of like alternatives to verifying the identity of the people that are using your application. So one of those is signed queries that we've gone over, where you're signing the view call and sending it over. But you could also use like viewing keys. So I know Secret Network, for example, make you set up a viewing key. So when you create a token, or when you interact with a contract, say like a token, you set a special key that allows you to view your balance. So you can send that over along with your request to see your balance, and the contract goes, yep, that exists. But there's a problem there, which is like the chicken and egg of, in order to see your balance, you have to interact with the contract. But if somebody sends you like $100, you need gas money to set up the viewing key to see your balance. So it's really not user-friendly. It leads to situations where someone sent you balance, but you're not sure how to see it, and every time you change wallets, you have to set up new viewing keys, and it's really awkward. So like the alternative here is, you might have seen this with a couple of different NFT markets, which is like logging in to verify your account. So if you imagine on a day-to-day basis, you make or every time the user goes to the website, they say, please just verify your wallet. Is this you? Once you've verified signed from your wallet, just say, I'm logging in for the day. It's valid for a week. Then you pass that along with all of your view calls. So it does require you to sort of re-architect your application or rethink it in terms of how you're querying the data. If you're performing lots of calls in batch, that's usually easier, because that won't have like pop-ups going, please sign the query, right? And then the other option is like permits and delegation. So if you want to give control to somebody else to be able to spend on your behalf, you have to think of, well, I've got allowances, but how do they know if I have the balance? Do you want like more fine-grained access control where you can give somebody access to a specific subset of features? And yeah, it's an outstanding problem that you're going to have to think about. But anyway, if we move on to that's like an introduction to the problems you're going to encounter if you went through the example of how do I create a private token. But next is the precompiles. So precompiles are sort of the special features that the Sapphire blockchain has that are unique to it. So Ethereum has a lot of precompiles, and they're simply there because it's too complicated and expensive to do this all in Solidity. So for example, the EC add and pairing operations are very expensive, but when they're written natively, they're super cheap. SHA-256 and EC recover, also examples. And the precompiles are all documented on our website. If you want to access them from your dApp, you're going to want to add the Oasis protocol Sapphire-contracts package, which gives you access to sapphire.sol, which is a wrapper for the precompiles. And of course, to test the precompiles, you're going to need to use the Docker image to run the Sapphire node locally. But the precompiles we have are like encryption and decryption. So if you're running a confidential contract and the contracts can have their own secrets, then yeah, being able to generate keys is something that you'd like to have. Being able to encrypt and decrypt information is absolutely necessary. You can do signing and verification, so the contracts can generate a key and then sign for something by itself. And of course, the random number generator. So with a random number generator, it's super simple. Just request a number of bytes, and there's a personalization string as well. So you can, I don't know, add extra entropy, whatever you want to do. We also got encryption and decryption. So you can use the X25519 key negotiation to derive a shared secret between the user and the contract, or two contracts together if they want to encrypt things for each other and pass it through the user. And there's a lot of other interesting use cases. So with ECDH, just a quick overview of, because we've got the full set of curve operations inside, you can not only do ECDH, but sort of general purpose cryptography. So anything that you see that uses elliptic curves, you can do in confidence with the ECAD and ECMOL operations. So for decryption, again, the Sapphire wrapper provides some really simple, straightforward tools. So you can generate your key pair and then get the public key. And then to decrypt, of course, you derive a symmetric key. So the client passes in their public key. You, after previously getting your public key, you derive the symmetric key, and then you call the Sapphire.decrypt function. It's really straightforward in TypeScript. So these are all code examples. If you want to copy and paste, they do work, and it should get you started. So with signing and verification, we support a number of different algorithms. So the ED25519 curve, which is used by Monero, for example. I think Cosmos uses it as well. I think Polkadot may use a variant of it. X25519 as well, which is a slightly accelerated version of the Edwards curve. Then we also support the Bitcoin and the NIST curve. So this is the NIST curve is coming up in the next version of Sapphire, which supports WebAuthn. It supports like TLS. So if you use SSL on a daily basis, you're probably interacting with the NIST curve. And the Bitcoin curve as well. So that supports generating Bitcoin wallets, verifying Bitcoin signatures, generating Ethereum wallets, for example, and signing from them. So both signing, verification, and key generation are supported. And of course, yeah, like Touch ID is something that's really, I mean, it's slow, because you have to write it in, without support for the NIST curve, you have to write in Solidity, which costs a lot of gas. But with the built-ins, I think it's like 2,000 gas or something to generate a signature from a NIST curve, which is really cheap. So again, if you want to sign, we've got the algorithm selection. So we support a variety of different algorithms. And when you're using the Sapphire wrapper, you have to specify specifically which algorithm and variant and curve you want to use. So we support, again, a variety of different algorithms, and they're documented in the documentation. And so in order to generate a key pair, we need to provide the entropy for this. So this is essentially the secret key. So if you're generating a secret key, get some random bytes, give it to the generate key pair, and it will give you the public and the secret key, which you can then use to sign from. And to verify, it's, again, really quite simple. If you use the Sapphire wrapper to perform the verification and pass in public key, the digest, and the signature. And there are different variants of the signing and verification algorithms either take like the pre-hashed message or they take the raw message itself, and it depends on the protocol, on the algorithm you're using. But so this is all like the necessary stuff that we need to understand, and in order to be able to do the more interesting stuff. So like integrating with Web 2 is like a difficult topic with like the Web 3 industry as a whole, because you've got like the Web 3 way, then you've got the Web 2 way, and like really like Web 2 is like there's no plugins, it's super easy to use. Your grandmother uses it every day. It's on every device, so you don't have to, you know, if your TV, for example, has a browser, most likely if it's a smart TV, like refrigerators, but they're all using usernames and passwords. So you've got like the Web 2, which is all usernames and passwords, the Web 3, which is all, you know, key pairs and signing, and they don't sort of mesh well together. But with confidential contracts, you can have end-to-end encryption. So Web 2 assumes that with SSL, you can securely submit stuff to the server, you trust the server, and if it's a contract running in a trusted enclave, then you can take the trust out of Web 2. So for other use cases like you know, OAuth, S3, JWT, you can generate signed cookies, for example. But you also have to be aware of like brute force attacks. And then, because on Web 2 you don't assume that everything is private, it's a problem. So hopefully if we look at Web 2 integration with Sapphire, because it's got confidential contracts, this should help the two worlds sort of mesh together a bit better. So I mean, the first example that came to mind was TOTP. So this is one thing that you can't do on Ethereum, because in order to generate like the two-factor code that you use in your authenticator app, the contract needs to know the same secret as you. So this is something it's really annoying that it's on every device, or every Apple and Android device. You can download the authenticator. It's used by loads of services, but you can't use it on Ethereum, which is annoying, right? So if I wanted to give my manager a TOTP code, and if I want to perform a transaction and I need his authentication, so his authorization, it's easier to phone up and say, hey, can you give me the TOTP code? I need to make a transaction. And this sort of model that we're used to working with is more complicated with the Web3 stuff. Because, again, your managers might not be Web3 natives. You might have to, they might be on holiday, they might not have internet. But with TOTP codes, this is really straightforward. So another example I said was the Amazon S3. So loads of people use IPFS, and now we've got like the IPFS pinning services where you can make sure that your files don't disappear over time. But the rest of the world, they use Amazon S3, Google Cloud Platform, and their storage solutions, where you might want to be able to provide an S3 bucket and let people upload big files to it and generate a secure link that you can give to the person that allows them to upload one specific file. Or if you wanted to do confidential NFTs, for example, if it's stored on S3, you can set up access controls. So upon purchasing the NFT, I can say, hey, give me the link for the full file, and it will give you a download link that's limited for 24 hours, for example. Because the contracts have the confidential data, they can keep the S3 secrets, they can generate links, and it opens up some interesting options. The other example is JWT. So if you've ever dealt with like REST frameworks, APIs, integration, loads of people use JWT, and it's another sort of pervasive Web 2 standard where this is just how it works, because they assume that the server has secrets. They assume that somebody's there going to be generating keys, signing stuff for you. So imagine like a smart contract that can generate access control. So if you want to sign up for online, on chain, you want to sign up for some API, and you want to get an access token to perform API calls, the token, it can do this now. So you don't need to have your Web 2 infrastructure be like aware of Web 3. You just have the contracts that work with your existing infrastructure, but can control access and can do stuff in return for money or whatever kind of integration you want to do. So this brings up the topic of like sort of gasless meta transactions, which I know is relatively popular at the moment. And that's essentially like towards the like contract autonomy. If you've got the signing, you've got the key generation, you've got the confidentiality, and you can generate Ethereum-compatible wallets. This means that you can sort of sign for transactions, which is interesting. So, for example, you've got a user interacts with our signing contract, and we say, hey, can you create a transaction for me? So the contract, using its key pair, will sign a transaction where maybe the user can control some parameters, or you're doing a swap, or it's acting on your behalf. It gives you the signed transaction, which you then submit back to the contract. Well, in this example, I just created a small function where it generates a transaction that calls its own function. So like, think of like anonymity. If you've got the contract that's signing for you, you don't know who invoked the contract to get the signature, because all of the signatures come from the same signer. And of course, this works on other chains. So you can have the contract on Sapphire generate signatures, push them over to Ethereum, and then everything looks like it's coming from the contract, which abstracts it away from the individual users performing the actions. So yeah, this is included in the Sapphire contracts package. So you can generate an Ethereum key pair and then use the EIP155 signer to construct the transaction and to sign it with your address and your secret. And this is just a super simple example of how do I generate my key pair. I import the Ethereum utils.sol file, and then I perform the signing of. So this is signing just a general message. So you could implement EIP 712, or you could sign arbitrary stuff, and it can do that. Or you can sign an EIP 155 transaction, so that's compatible with most Ethereum compatible networks. So Ethereum, BSC, Polygon, etc. And the problem here is that the contract doesn't know like the gas price. So if you're signing a transaction on a remote chain, you need some way of knowing, okay, so what's the account nonce? What's the sequence? Because if the contract's like autonomous and it's in its own sort of little isolated enclave, and it doesn't have oracles, so how does it know that, the gas price you give it is not going to just, take all of its gas paying balance away? Or how do you know that someone's not going to do something malicious or deliberately submit transactions with low enough gas price that are going to stop the contract from submitting any more transactions, right? So this is something you have to look out for. I mean, if it's your own contract, it's your own funds, and you're using it to delegate signing to some kind of multi-factor authentication, then you can provide whatever gas price, whatever nonce you want, and it's up to you to decide. So we actually got a demo of this where we figured that one of the problems was you can't expect people with so many different chains to, if you want to use private voting on Sapphire, you've then got the problem of everybody needs to get some gas to pay for the transaction on Sapphire to submit their votes. So if you want, I can give you an example super quickly of essentially the secret ballot. So I'm logged in, I vote. It pops up a notification and says, this is a proposal, the voter, the choice is McDonald's, using EIP 712. And then this is one thing you'll run into, which is view call. So it's signing a view call, which is sort of like a bad UX problem of, because you've got the signer attached to the provider, whenever it performs a view call, it will ask you to authenticate it. But so we're signing something, but we're not submitting a transaction. We're not using any gas. And I actually have 0 balance here. So I sign this, and behind the scenes, the contract's generating the transaction to submit your vote on chain. So it's like a sort of gasless meta transactions. This brings us into account abstraction. So with the contracts that have their own secrets, they can manage keys for you. I've another demo I've got set up, which is WebAuthn. So we've got a full account abstraction example where using a YubiKey or using passkeys on your phone, you can get the contract to sign messages for you. So this is where, like a hardware security module, you don't actually have the secret key on your device or any other thing. So only if you log in through using WebAuthn or passkeys can you get the contract to sign on your behalf. So in terms of customizable logic and both TOTP, WebAuthn, these can make some really interesting situations where you can give the contract control. So if you want to have spend limits of, say, $1,000 a month, you can have the contract only sign transactions for up to $1,000 per month before it stops completely. And so because it's signing real transactions, this means you don't necessarily have to have the contracts deployed on every single network that you want to operate on. You can have a single contract on Sapphire that signs transactions on loads of different networks. So I could have a contract on Sapphire that authenticates me to sign on Ethereum, and it will do that for you. And I missed an example there. So the next problem we have is we'll cross-chain. So Sapphire exists in isolation, so we need a bridge, basically. And this lets you keep some of the stuff that you need to be private on Sapphire, so you don't have to migrate your whole application onto Sapphire. And because it's a message passing bridge, you could send a message from Ethereum to Sapphire and say, this user wants to do something, please handle this for me. And they want to do it in private. The user will go and do something in private, and then submit the result back over to Ethereum with whatever the result is. Which means you, again, with smart privacy, you get to do the private stuff in private and the transparent stuff in public. So you don't have to rely, if you want your assets to be on Ethereum or on Binance where it's secure, that's where they live, then you can do that and move, say, a part of your DEX over to Sapphire, or, I don't know, it's interesting. So this is like fairly straightforward. Again, the Sapphire contracts package includes everything you need. And under the hood, we're using the Seller IAM bridge to pass messages to all the chains they support. And you just need to use opl.sol. So we've got the user, which submits the request to the dApp or the dApp plugin, which sends it to the message bus, which emits an event, which is picked up with the State Guardian network. So this is Seller's sort of multi-chain verification system. The executor sees that the State Guardian network has authenticated this message, which submits it to the message bus along with the State Guardian secrets on the destination chain, which will then invoke the dApp plugin. But who runs the executor it's not a gasless solution, so you have to run an executor yourself or get in touch with Seller to run an executor for you. It's fairly straightforward. So you post a message, which can be anything, and we're using messages and the methods. So the methods like the message destination title. But the two contracts are linked to each other. So I'm going a bit fast now. So the two contracts are linked to each other. So you've got one contract on the enclave and one contract on the home network. So you have to provide the addresses of each other to each other when you construct them. And you can predict what the addresses are, can be ahead of time, so it's not too much of a problem. And essentially, you register your functions that you want to be callable in the constructor. So you want to register your endpoint, say the example, the Sapphire example endpoint, which then on Binance Smart Chain, you can say, invoke this, it will post the message along with the arguments, which will then be called, and you can return success or failure, depending on the status. But really, I want to get on to some of the more interesting cases, which is like roll-ups and scalability, which is, loads of people are doing ZK roll-ups, and that allows you to compress the computation of lots of different things and then bundle it up into only the information that you need to be transmitted. So the account differences, so the differences in the balances, or you don't have to include all the signatures because you know that the transactions are valid. But on Sapphire, there is some interesting things you can do here. So because the ETH call is free and the contracts have access to private state, that means that you can get the contract to sign stuff for you. So one example is you could provide the contract's previously signed output to the contract again and get it to sign that along with the next piece of work. So the example here is it will allow you to condense all of that information into a single signature provided by the contract. So if we look at a Bitcoin Lite client, for example, if you want to run a Bitcoin Lite client in view calls alone without modifying any state, then you can pass all of the blocks one by one to the verifier contract, which verifies the proof of work is cumulative. It verifies the consensus algorithm, and it provides you provide it the previous proof of the verifier client to it, and then any signature that it outputs, you can verify that this has been running for 2,000 blocks. The proof of work is this, rather than having to submit all of the blocks to back again. So an example is if you want to synchronize the Bitcoin Lite client on Ethereum, you have to set up the verifier, then you have to shuffle in all of the blocks, and you have to keep providing the blocks for it to verify that the block hashes you're providing are correct. But if you run this on Sapphire, you could have the Lite client on Sapphire running, and then if you trust the signature of the Sapphire contract, then you can have a Bitcoin Lite client on any other network as long as it trusts the signature, without having to relay all the blocks again. So there are lots of other examples, if you want to talk to me about this, of where rollups on Sapphire with confidentiality can let you do things that are just not really possible in a gas-efficient way on other chains. So, I mean, some of these examples are like shortcutting messages. So if you think of a protocol where the contract's going back and forth and back and forth, you could use view calls on Sapphire to, say, verify the state. And because you can pass information back and forth and back and forth, you can have an entire round trip going on between you, maybe 3 or 4 other parties, with the contract encrypting data to pass back to it that can be securely passed through other people's hands without having to worry about it being tampered. So if you can do this without having to modify the state, then it's basically all free. And it's only costing you gas when you need to start making modifications to the global state. So if you think of like the typical 2 or 3 phase commit process, you can condense this down into like one step with Sapphire, where because it can mediate, it can generate keys, it can encrypt information, you don't need all of these round trips. So that's, in terms of like scalability, instead of waiting for your transaction to be mined and the limit being the number of transactions that can make state modifications at the same time, instead you can spread your queries across all of the different view nodes and you get scalability to the relative to the number of nodes in the system versus relative to the number of state modifications it can make. So I should also add that we're running a hackathon at the moment. So it's started already, and it's going to be running up until October the 4th. And there's $30,000 in prizes across 4 different categories, with 25 grand in follow-on support and grants. And there's going to be free audits for successful projects. So the 4 different categories are, you've got the best app on Sapphire, so it's anything that's native to Sapphire that uses the private storage, the RNG, encryption, signing, etc. There's also the best app that uses OPL, so if you have an application already that you need to make some bits private, you can use OPL for that and submit it to the hackathon. There's also like the best use of Sapphire for scalable privacy, so what I've just said about rollups, it's also confidential, right? So you can do lots of things in private very quickly and then submit the results to, say, Ethereum or Binance, and that would be a huge speed up versus doing them all on those chains individually. And then tutorials and standards. So I've learned that if I'm doing a hackathon and my project doesn't quite work, I can turn that into a tutorial. But there's also the opportunity for standards where there's lots of stuff that needs reimagining because of the privacy aspect, because of the confidentiality, where like the token standards, you can use them, but they won't be private. The NFT standards, like, are there any options for confidential metadata? This is just lots of some examples there. But yeah, there's 25 grand in follow-on support for runners-up and winners. And yeah, that's the link for that. And thank you, that's me done for today. Yeah. So I think we've got 15 minutes left. So if anybody has questions, or if we can sit down, or whatever you want to do, I'm happy to answer any questions you have. Yeah.
Thank you.
Oh, can you get the microphone? Sorry.
Thanks. It was heavy workshop in terms of information.
Yeah, I'm sorry about that.
No, it was super helpful, and you touch on a lot of things that at least our team is thinking about and struggling with, at least on alternative chains.
Yep.
My question is super general. I just was wondering, have you seen people build non-financial applications?
Yeah, so in terms of the applications out there, like finance obviously is one of the main use cases, simply because it's so integral to everyday use. But outside of that, it's, well, I mean, I'm honestly struggling to think of use cases that don't involve DeFi or don't involve finance in one way or another. Simply because, you know, without any money involved, the stakes, you have no stakes. So there's less need for trust, less need for confidentiality. But you can look at voting. So if you want to keep the votes private while the vote is active. So in most elections, your vote is private forever, you know, and you can't see people's votes. But with Web3, that often ties back down to how do we spend money and how are we voting on that, right? Yeah.
I was thinking of voting examples or personal data management.
We were looking at like password managers. So being able to, say, delegate access to your passwords or a specific password for an amount of time. That's something that's come up. So I think we should wrap this up. No more questions. Cool. Thank you for coming today. And please come and talk to me, and we can talk about the hackathon, and if you have any interesting ideas, and point you in the right direction. Okay, thanks, guys.
one. I don't know if I should see it or not. Hello. Welcome to Developing on Safe Core Protocol. I'm Germán, like German, but I'm not German, I'm Spanish. I work as DevRel at Safe, and today we're going to talk about the Safe Core Protocol. Can you raise your hand if you have heard of it? Okay, pretty good. Pretty good. So there are so many questions, like different terms and concepts that were recently introduced, like a lot of them, like plugins, modules, the manager. There was even a white paper. Have you read it? Okay, good. Today, we are going to talk about the Safe Smart Account, refreshing a little bit what it is, what are the different elements there. Then talk about the Safe Core Protocol, what are the new things, the new components, and how they are connected to the Safe Smart Account. We are also going to see some resources, some repositories where you can find the contracts, some applications that use it. And then we will see a demo, and if you brought your laptops, you can also follow me and play with it. So let's start with the Safe Smart Account, which is a modular account framework. There are different elements there, being the most important one, or the main one, the account itself. In this case, it is the safe contract. But then we can extend the functionality, adding different other contracts. For example, modules. Modules allow to extend the functionality by triggering transactions that are sent to the contract, and in a way that you could bypass, for example, the regular flow where the signers need to approve all the transactions. And with this, you can, for example, automate transactions and do much more stuff. One example of a module would be a recovery module that could, at some point, trigger a transaction that replaces an owner that was in the account with a new one, so you can get access again. There are different elements, like the transaction guard. Transaction guards allow to add extra logic when transactions are executed. So this logic can run before and after the transaction is executed. And they can parse the transaction, all the properties, the data, like what is the destination, the value, and also see the state changes in the contract and act on it and decide if the transaction is executable or not. An example of a transaction guard would be an allow list guard that checks what is the destination of the address. This guard would have a list of addresses, and if the destination of the transaction is included, then it will be available to execute, otherwise not. And lastly, we have the fallback handler, which is a contract that can be enabled in the account and would handle all the calls to functions that don't exist in the main contract, but are implemented in the fallback handler. And this is very useful if new, for example, standards for tokens are implemented while you have already your account deployed. They require you to add new functions to the contract that you don't have them implemented, and you could do it that way. So this is how the Safe Smart Account looks. I hope we will all agree that modular smart accounts fail without three things: interoperability, discovery, and security. interoperability, because there is a risk of vendor lock-in if different projects are doing their own thing, then that are not compatible between each other, then the ecosystem will end up with a lot of tools and very fragmented. And also there will be a lot of duplicate work that won't be reusable. Regarding discovery, there's no, currently there is no central place where you can search or discover these elements like plugins, etc., for smart accounts. And this also leads to a lack of distribution to users. And security, we need to make sure that all of this is secure and the funds are not at risk. Now that we have seen the Safe Smart Account a little bit, an overview, we're going to talk about the SafeCore protocol, which is a modular smart account protocol. Some things first. It is in version 0.1 alpha, so it's in a very early state. This means that it's ready for hacking, but not for production use yet. So we expect things to change and to break in the coming months. Also, while the protocol is meant to be account agnostic, for now we will focus just on Safe, the version is 1.x, to speed up the development. It is open source, and right now we are seeking for community feedback. It's the best time to do it, as we are still working on it, and your suggestions are very welcome. So this is how the Safe Smart account looks like. And now we are going to see how the SafeCore protocol is connected to this. So instead of having modules, guards, and fallback handlers enabled directly into safes with the SafeCore protocol, we will have a manager. The manager will be the element that is placed in the middle and will coordinate all the communication between these different components and the account. It will also, well, we have a Safe Protocol Manager implemented that you can check. It will also access to registries. Registries, a registry is a contract that can define a list of modules, different elements that we will talk about later. Registries will have an owner. This owner will decide which elements to include in the registry. And these owners can be like individual accounts, multi-sigs, for example, if there's a council managing this registry. Ideally, DAOs would have their own registry, or registries would be managed by a DAO, so they all decide together what to include or not. They will define some requirements for developers that they need to meet in terms of security. And we have the Safe Protocol Registry implemented that you can check as well. And now we have the modules. Modules are these external components that will extend the functionality of the Safe. There are different types here, and you will see some relations between these new ones and the ones we saw before. For example, plugins. Plugins are kind of an evolution of the modules we saw before in the account, as they can be connected, in this case, to a manager and send transactions to the Safe. The difference between them is that plugins must be added to a registry, and accounts would be to enable these plugins in the manager, and then the transactions will be sent from the plugin to the manager and to the account. While in the Safe Smart account, we saw that the modules were connected directly to the Safe. We will see why this is beneficial later. So for plugins, for example, we have a recovery plugin that would do the same action as we saw before. We also have hooks. Hooks would be very similar to the transaction guard. So we can have here an allow list hook that will check the destination of the address for every transaction and act on that. We also have function handlers which are similar to the fallback handler. And we have the signature validators and some others. In the future, we will be able to have more different type of modules. Now we are going to see different flows, like adding a plugin to a registry, how to enable a plugin in an account once it is included in a registry, and then how executing a transaction from a plugin looks like. So let's start with adding a plugin to a registry. Here we have the different components, the safe, the manager, the registry, and the plugin. And to add a plugin to the registry, we just need a call to a method add module in a registry, and that's it. It looks easy, but it's not that easy, as this will be the most bureaucratic step, probably, for developers, as they have to not just convince, but prove they are worth to be included in the registry. So here, the owners will decide if they accept or not the request they get, depending on the criteria they decide, and then the owner of the registry can call this method to add it. Now, once we have the plugin added to the registry, we can, as users from an account, enable them. So here, we would need to call the safe to execute a transaction that will call the manager, the method enable plugin, and there we will pass the address of the plugin we want to enable in a safe, and a Boolean property that is called allow root access. What is root access? This can be true or false, depending on the permissions we allow the plugin to execute. And this is very similar to when we are, if you are developers, when we write a command in the command line and you want to have some extra privilege and you add sudo before it. So, for example, if you have a plugin with root access, this plugin will be able to execute delegate calls. Otherwise, they won't be able to do that. Also, if you have a plugin with root access, you will be able to execute transactions where the destination is the manager or the safe. Why is this? Why do we need root access for this? Because if the destination is the manager or the safe, the plugins would be able to will have access to functions that are quite critical, like enable a plugin, disable a plugin, adding extra owners in the safe, or removing them. So we would only allow this if a plugin has root access. If they don't, they would be able to execute regular transactions. Once the safe calls the manager to enable the plugin, the manager will check if the plugin the safe wants to enable is included in the registry, because that is mandatory. Also, our implementation of the registry has a property for each plugin that is where they can be flagged or not. And being flagged, if a module is flagged, it means it's not usable. It's marked as blocked. For example, if there's a registry with multiple modules and somebody finds a vulnerability for one module, for one plugin, sorry. Well, modules. The owner of the registry will be able to block this module for all the users, for all the accounts, and nobody would be able to exploit this vulnerability. This is quite an improvement, because in the past, in the Safe Smart account, where modules are enabled to safes directly, if there's a vulnerability found, then every account should be responsible of disable their module individually, while here, the owner of the registry could help do that with just one action. Once we check if the manager checks in the registry if the plugin is in the registry and then also is usable and not flagged, the manager will ask the plugin if the plugin requires root access or not to store this information in the manager. So the manager will end up with information like this account has enabled these one or multiple modules with this type of permissions. For now, we just have root access, which will be yes or no, but in the future, different kind of permissions could be defined as well. And now we have added a plugin to the registry, enabled it into an account, and we will see how to execute a transaction via the plugin. So here, somebody will call a plugin, the method exec, for example, that will send a transaction to the manager. Two things can happen here depending on the permissions the plugin has. The plugin can call the manager, one of these two functions, execute root access or execute transaction, passing the safe address they want to send this transaction to and the transaction. And here, this transaction object can also have some metadata of the plugin. So later, when the transaction is executed, some events can be emitted with this metadata, and the applications in the front ends will be able to add more, to be richer with more information and with more context about the plugin and the transaction. The manager, once it receives the transaction and the safe the plugin wants to call, it will check if the plugin is enabled in that safe. It will ask the registry if the plugin is added and also not flagged, so it's usable. It will check the plugin if the plugin requires root access or not, and it will compare that with the information it was stored in the manager before to make sure that the function that was called, it's OK and makes sense. And if everything is correct, then the manager will tell the safe to execute the transaction that was initiated in the plugin. Is it clear, or do you have any question so far? Yes? Great.
Will there be only one registry? Or can I have my own registry?
For all these components, we have interfaces, and there could be multiple implementations for them. So for example, the registry, we provided code or one implementation for it, and then many people can deploy their own registry with that implementation, or even with a different one, as long as it implements the required interface that is provided. And ideally, we will see in the future lots of registries in different contexts. So they list all the relevant modules on that topic. Yes?
So in this protocol, do I necessarily have to block the manager and then have this exact transaction per module, or can I still, as we can do today, stop what you say directly?
OK, I will repeat the question just in case. So you're asking if this replaces the old setup we have. And the answer is no. This doesn't replace the old setup. It's just an addition, an improvement, but both will coexist. Well, let's see how the next versions of the safe evolve, but for now, both can coexist. And in fact, this one will still uses the smart account to connect the manager to the safe. We can see that later in the demo. But yeah, we have another question there.
Yeah, sure. Is it always a one-to-one relationship between safe and manager, or can there be many safes for one manager?
Technically, one safe could have multiple managers. Yeah, this is getting complex. In theory, it's just a one-on-one relation when a safe has a manager that has access to a registry. But technically, you could have multiple managers, each manager accessing to one registry, or even, depending on the implementation of the manager, the one we have just has access to one registry, so one manager, one registry. But depending on the implementation of the manager, it could access to multiple registries, so this can really get more complex. But yeah, to understand it, it's like one safe, one manager, and one registry. But this can grow. let's continue, and then if you have more questions, we can answer them. So as I said before, these components have an interface, each of them, that needs to be implemented. And I will talk a bit about the plugin and the manager ones, which are the more interesting ones if you are implementing a plugin. So for the plugin one, there are 4 functions that you would need to implement, like name, version, metadata provider. This will tell the one calling this method where to find the structure of the metadata for the plugin, and this can be different things like the name of the plugin, the version, or whatever. And then if the plugin requires root access or not. Regarding the manager, there are 2 functions that must be implemented, execute transaction and execute root access, as we saw before in the diagram. One difference between these is that for the root access transactions, you can just send one transaction at a time. However, for the execute transaction function, you can send a batch of transactions, and all of them will be executed in the same transaction. Also, in the Safe Protocol Manager implementation, we added more methods apart the ones defined in the interface, like some management for the plugin. You can enable and disable plugins, get information from a plugin, and so on. Let's see now some resources we have with some repositories. There are 3 repositories about the Safe Core protocol, and the last one is a demo. The first one, the Safe Core protocol, it is in the Safe Global organization in GitHub, and there you can find the contracts we implemented, like the manager and the registry, like the Safe Protocol Manager and Safe Protocol Registry. Also the interfaces for the different components that you would need to implement if you want to have your own implementation. Then we have the Safe Core Protocol specs repo, also in the Safe Global organization in GitHub. There you can find documentation about it, some diagrams, flows that are very interesting. Also, I forgot to say, in the Safe Core protocol, you will find tests that are very useful to see how that works. And then we have another organization in GitHub that is 5AF, like Safe, for more experimental things. And there is a demo app, Safe Core Protocol demo, that we will see in a bit, where you can play around. There are some examples for plugins, and there is a Safe app that you can try with some front end. There's a registry, and you can play enabling and disabling modules from there. The last one is the URL for this demo, but we will check it in a bit. Also, if you have your laptop today and want to do the demo with me, we have a POAP you can get to be a kind of protocol tester at Berlin Blockchain Week 2023. There are some requirements you need to meet, like fill a survey to collect some feedback from your experience here and what you think about the documentation we have. And also enable a plugin in your Safe. If you want to scan this survey to participate, you can do it now. And well, maybe at the end, if you don't have time now, I'll be happy to provide this QR code again. OK, so now it's the demo time. If you have your laptop, let's open the Safe app. I have it open here. You can go to app.safe.global. And we can create a Safe in Gurley. If you have any issue, just raise your hand and we can check it together. or feel free to interrupt me if you don't understand anything. So let's create a new account that I will call Safe Workshop on Girly. I'm very happy that we have a relay working on Girly, so you don't need funds to deploy it and even to execute transactions. We have 5 transactions for every hour. So right now, the transaction is being executed, and I will have my safe deployed on Girly very soon, and without funds from my side. Is it all good from the computers? Are you deploying a safe? Yes? OK, great. If you also have some funds on Girly, once you get the safe deployed and the safe address, it would be great if you can send just a little bit to your safe, not to pay for transactions, but to be able to execute a transaction that sends something. Otherwise, you won't be able to create a transaction if there are no funds there. That is not mandatory for the demo, as it's only required that you enable the plugin and not execute a transaction via the plugin, where you would need some funds there to send something. But if you are able to execute the transaction, then that would be funnier. So I will do that. I have my safe here, and I will send some funds. If you don't have funds to send, I can give you some Girly ETH. I will send a little bit. I know what happened. I don't have funds in my MetaMask, but I have another safe with some funds. OK. Yeah, the thing is that I have funds in a safe, and I want to send them to the other safe. But using the relay would be fine, right?
I think the relay is IP-based. That will get issues. Can you send me your address, and I will send you 20 Girlies. No, you can't. Oh, wait.
Just show us the QR
code.
Yeah.
But that's of your safe, right?
Sorry. Yeah. No, it was fine. I don't know what I did wrong. I had a save with Ether enough to send it, but I guess I was confused with something. It should work. Okay, do you have your save deployed? Can you raise your hand? Yes, okay. Do you have some funds on it? Yes? Okay. Now let's see the code of the repos that were shared before. I have them here. I can share the links again with you. These ones, if you want to take a picture, to have them later.
Which one should we open now?
Well, there's no need to open any of them, but because we don't need to program anything. But I will show them a little bit. Yes, so in the SafeCore protocol, we have different folders. We have some contracts with what I said before, the Safe Protocol Manager. You can see the implementation we have for now. Again, expect things to change in the coming weeks and months. Also, the registry, you can find it here with the implementations of the functions from the interface. There are also some tests for the, for plugins. There's a registry that is unrestricted, so anybody can add a plugin there without the action of the owner of this registry, etc. Then in the protocol specs, you will have the diagrams and flows. And now we can see the SafeCore protocol demo. Here there are contracts and web folder. In the contracts, you can see some implementations of different plugins for testing. For example, there is a relay plugin that works with Gelato that allows to relay transactions. Then we have a plugin for recovery that replaces one of the owners of the account. We have also a whitelist plugin that you can check. And then we have the source, the web folder here with a front end that is a safe app. Now I remember. You need to copy the last URL here, the 5ave.github.io, and then save core protocol demo. That you will need to use it in your front end. Does everybody have it ready? Okay, so we'll add it as a safe app. If you go to apps in the front end, then there is my custom app. I just added it before, but you can do it as well. You can click on the add custom safe app and provide the URL there, and then click the button add. All good? Let me know if you have any issue with that. So now, if we open this, it will show us a safe logo rotating, and then there's a link, show available plugins. Yes, here, if you go to the menu apps, my custom apps, there's a button. Yes, the URL is, the last one is 5ave.github.io, and then save core protocol demo with hyphens. .github.io and save core protocol demo. And then you will see the app added here. So if we open it and click on show available plugins, we will see a registry with different plugins added from a hackathon and some tests. Now, I want you to enable the relay plugin, this one. Can you see it? Yes, is there a button enable that will create a transaction? If you see, before executing this transaction, it is a batch transaction that will enable module and enable plugin. The enable module, something somebody before asked, is the manager replacing the old setup? No, the manager here is added as a module in the Safe app, in the Safe Smart account. So we need to first enable the manager and then enable the plugin there. So we can execute this with the relayer as well, with no gas needed from our side. Sign the transaction. It failed for some reason. It's just awaiting execution. No, but OK, I will try to execute it with my funds, but this is weird. It looks like it's now processing. Yes. Were you able to enable the plugin to execute the transaction? Yes? Great. OK, now if you go to the settings and go to modules, you will see the Safe Account modules there. Yes? That is the manager. Also, if you want to go to EtherScan, to this contract, and read it, there are multiple methods there you can check. One is plugin enabled, and there you can copy-paste the safe address and the plugin address. The plugin address is in the... Well, it doesn't matter. You can check it by yourself if you want to play with the contract functions more in detail. But the plugin is added to the manager, and the manager is enabled in the account. So now we go back to the demo app. And because of the metadata of the plugins, we can have a link that is pointing, as a metadata of the plugin, we can have a link pointing to the front end for that plugin. And the relay plugin has one link here on the right that will open an interface to relay transactions. So we can define, for example, a max fee of 0.1. This is just the logic of the plugin.
What does this plugin do?
This plugin works with Gelato and will allow to send a transaction. You can call the plugin, send a transaction, and it will be relayed. You can have check the code here in the Safecore protocol demo, contracts, plugins.sol, and it is this one, the relay plugin. So this plugin will send the transaction to the safe account, and the safe account will send the transaction to the Gelato relay. So the transaction will be executed, and also the safe from the funds that are inside, it will repay the executor, or it will send the fees to the fee collector from Gelato.
How is it possible to deploy this fee token with an address that only consists of keys?
Sorry?
The fee token here
Yes?
has an address that's only made up of keys.
What do you mean? That is the token you want to use to repay the relayer.
That's not a deployed contract. So the keys, when you go to Gelato and some other protocols, they have placeholder addresses that represent the native.
Okay.
And this is Gelato uses keys for Ether, or they use a zero address. It's just basically placeholder address indicating that it should use the native.
Okay, thank you.
So in this case, yes.
Okay, I was not understanding the questions. Yes, this is a list of tokens, and then if it's the native token. So now we don't have pending transactions to relay, but we can go to here to create a new transaction, to send tokens. This is why you need some funds in your safe. This is not required to get the POAP, but we can try this. I will send it to myself. And instead of executing it, I will just sign it. So we can execute it via the plugin. I'm just preparing the transaction. Okay, it was added to the queue successfully. We can see it here. And now I guess we have to refresh this. Yes, we have a list of 1 items for the pending transactions that we can relay. So the transaction, it's been relayed. It will be executed by the relay. And then in the transaction list, we will see the transaction that I executed, sending some funds to myself, and then how we are paying the fees to the fee collector. So if we go to transactions, to the history, now see here, we see that I was sending some girly to myself, and then paying the relayer. So this was an example of a relay plugin, but then we can have many plugins implemented, listed in or added to a registry. With the metadata, we can add some information like a URL pointing to the front end for this plugin. And then applications would be able to read this metadata like this Safe App is doing, and allowing users to open it and play around with the plugin.
How did you use the plugin now? I missed that part.
How I use the plugin?
Yes, I have the transaction prepared.
There's a button. You need to refresh the front end. Okay, and there at the bottom you should see 1 transaction, yes, and a button relay.
But they need to open the Safe App, right?
I need to open the Safe App. Okay.
You need to go to the registry again and find this, you mean?
Yes.
Okay. Then here. No?
Okay, I see it.
Is it good? It's relaying. Okay, okay. It takes a little bit. Then that was the demo. Feel free to let me know if you have any issues, or your feedback as well is very welcome. Here you have the slides if you want to check them later at any time. We can talk to us on Twitter @safe, check our docs on docs.safe.global. We have Discord, a forum. And thank you very much for attending this workshop. And, well, thanks. And now if you have some more questions, now it's the time. Yes?
You mentioned...
Yeah, I think it's working.
Okay. You mentioned hooks in the very beginning instead of guards, or basically the new version of guards. Can we... I understood, I'm not a developer, but I understood that you can only have one guard right now. And can there be more hooks in the future?
If we will allow to have different hooks connected all at once so different checks can be executed?
Yeah.
There's nothing preventing us to do it. I guess it's just a matter of priorities. Here, the good thing about the protocol is that the interfaces are defined, and sorry, here, for example, hooks are called from the manager. So the flow would be, there's a plugin, the plugin calls the manager checks if the plugin is okay, and it will also check if there are hooks that need to be added to the registry and all of that. And then if there are hooks, the manager will call the hook. Depending on the implementation of the manager, if it allows to have just one hook or multiple, well.
But we are not there yet in alpha, right?
Sorry?
Alpha is not there yet.
No, right now there's just one hook. Regarding transaction guards, I know a project that implemented a guard that allows to plug multiple guards and call them in a loop. But yeah.
Okay.
Like you don't have to even have a loop, you can have a chain of responsibility pattern where you basically have your guard call the next guard and that guard call the next guard, and it's outside of then the safeguard protocol. Is just up to you how you stack them up.
Yeah, we stick to one guard and not teach this kind of asking one and one and one.
But it's up to you as the developer of the guard how you chain them.
Also, one interesting thing that I didn't mention in the workshop is that with the previous setup, when you were implementing modules, there was this decision of, do I implement this module just for one account or with data storage that allows to have multiple accounts connected? For example, the allowance module we have allows to have multiple accounts to reuse the same deployment of that module, but there were other modules where the account needed to deploy one instance of the module to use it. Here, we are making mandatory to deploy modules that are reusable, but many accounts, because they will be added to the registry, and then, well, that's it. Is there any other question? Also, we have our booth downstairs. Feel free to come whenever you want. We will be there. Thank you again.
shall we start? Nice. Yeah, welcome. Cool that you made it to my talk. Yeah, I'm going to talk a bit about how I'm planning to not break all your dApps in the future. The focus is actually on the not in the title that I handed over to the Gnosis team or the conference team. We forgot the not, so the focus is really on the not. We don't want to break stuff in the future, and this talk is mostly about how we are planning to achieve that. Next topic, in the printed out agenda, or if you looked last week at the agenda, you might have seen that the talk is about distributed sequencing. My colleague who wanted to do that talk originally couldn't make it in the end, so I'm taking over and I changed the topic to talk about data migration. I think it's also going to be interested, so please stay here. But you have to wait for the distributed migrated sequencers for some other conference. Yes, so now I already skipped a bit. Yes, short intro. I'm Paul. I'm working as a developer for cLabs in the blockchain team. We're basically taking care of a guest fork that runs the Celo blockchain. And yes, a short intro into Celo. Some people might know it, some people might never have heard of it. It's an EVM-compatible chain, basically, and it was one of the first chains that was carbon neutral. So we achieved that by implementing a proof-of-stake system in the days when Ethereum was still the proof-of-work chain. And this proof-of-stake consensus is based on the IBFT protocol. So besides this lower energy usage, that gives us some nice properties. One of them is one-block finality, which is really beneficial for people developing applications on top of the Celo blockchain, and also for users because they don't have to wait for confirmations and so on. And together with a current block period of 5 seconds, we think that's really user-friendly, allows a lot of use cases that have been hard to achieve on obviously Bitcoin with its block time from forever, but even Ethereum before. We think that allows some new cool things to be built. Another feature that I usually think isn't used enough and that makes onboarding a lot easier is that we have gas payments in ERC20 tokens. So you don't have this onboarding problem as you have usually in Ethereum, where people just want to send a transaction for whatever stablecoin that they own, and they have to get Ether and able to send transactions from their accounts. But on the Celo blockchain, you can just use stable coins that we offer. For example, we have a stable coin for US dollars or euros, and you can use those to also pay the gas price, the transaction costs. And obviously you need a different transaction type to do that, but still it's only used in a roughly 5% of all the transactions on the Celo blockchain, and I think it should be used more. I think it's pretty cool. Especially in the whole context of account abstraction that people are now talking in Ethereum. I think it has the same, a bigger scope, but it goes in the same direction. We're gonna make onboarding easier and allow people to not have those problems of needing to own Ether in order to send transactions. Yes, if you want to find out more, you can look at the website. It's celo.org, easy to remember. And a little shameless advertisement, on Wednesday morning, René, the head of the Celo Foundation, is going to have a talk about unlocking Web3 growth in Africa. It's going to be less on the technical side, more on the impact side, but there I think he's going to share a nice presentation. If you're interested in that stuff, please go over there. So, what are we going to look into during this presentation? First, why do I, as a developer working on the Celo blockchain, do have to care about not breaking your applications and smart contracts? And to understand that better, we're going to do a little deep dive into state handling, how is state working in the EVM, how do events work, and so on. So we're going to dive a little into the data structures of Ethereum. And after we understand that, we can look a bit into how can we migrate that state. And in the end, gonna have some questions. I mean, I've been more in the nitty-gritty details of the protocol layer in the recent times, so I lost a bit of contact to smart contracts and people building on the blockchain. So I'm hoping to get some insights how applications look nowadays and try to get some feedback from you. What do you think is important? What doesn't make so much sense, and so on. Again, the Celo blockchain historically has been an L1 chain, but we want to align more with Ethereum, and this has different reasons. So one of the first reasons is we historically changed some protocol things like the header structure in the blockchain. We changed that, which made RPC calls horrible because some tools could work with it, other tools couldn't. So we now want to get closer to Ethereum to basically make developers' lives easier, allow them to use the tooling they want to use, and so on. But additionally, also becoming an L2 would allow us to use the additional economic security that Ethereum offers us. So there's way more TVL on Ethereum than on the Celo blockchain currently. So becoming an L2 would allow us to use that basically for our benefit and allow for different use cases than are currently possible. Additionally, becoming an L2 also might improve some of the bridging story, which is currently a bit rough around the edges. And basically there's lots of investment going into bridging around L2s, and we hope we can use some of those. So on the right side, you basically see one of our on-chain governance proposals where we asked the community what they think about this. We basically wrote a forum post about this idea to become an L2, and actually it seems like the community is quite excited about it. But obviously there are some constraints, and these are the following. So currently transactions are quite cheap on Celo, so this is a requirement, and that actually means that we have to go a bit different way than current L2s or optimistic roll-ups like Optimism or Arbitrum are doing. So they're saving all the transaction data on-chain, on the Ethereum chain, mostly as call data at the moment. But this is so pricey that we basically can't do it if we want to keep current transaction prices. The next thing that's, as I already said, really important for us is this one-block finality. And current rollups can't really do that. So we have to change some fundamental assumptions there. And we think we can get kind of like a two-stage process. So if you don't need the highest economic security, you can basically have this one-block finality. But if you want the whole economic security of the L1, in our case, Ethereum, then you need to wait obviously a bit longer to get that benefit too. And the last point, and this is where the circle closes for this talk, is basically we already have a chain, we have lots of users, we have a lot of on-chain contracts that are deployed, and we can't start from scratch. So we have to find a way to migrate our state to this L2. So before we look into the state itself, just some stats so you can get like a feeling about what we're talking here. So Ethereum at the end of August on a full node, not an archive node, was roughly like a terabyte of state. An archive node usually 2 to 3 times bigger, so 2 to 3 terabytes. And the Celo blockchain is a bit smaller. So end of August was like nearly 200 gigabytes of state, 20 million blocks, nearly 300 million transactions. And I was a bit surprised by that number, that there are like 722 million events emitted. So that means that every transaction roughly emits 3 events, which I found surprising because I expected it to be less than 1 in average. But nice to look into those numbers sometimes. And usually, I think Ethereum grows by a couple of like gigabytes per month, the state. Celo obviously a bit less. And again, all these numbers are from full nodes, so they already have some state pruned. What that means, we're going to talk about it in a bit. But now you have a feeling for the stuff we're talking about here. So how is state actually stored? I think the stuff that people think about is, like the account storage, smart contract data, and so on. So this is the first thing, and we're gonna look a bit into how this is implemented in the Ethereum clients exactly. But for users and like people interacting with the blockchain, I think there's two other things, namely like transactions. People want to know, what have I done historically? What are the transactions I sent in the past? And also transaction receipts, including all the events that people or applications might use in different ways. So those three things are the things I want to focus on. And now let's look how this actually works. And I hope it's big enough. Can you read it from the back? Yeah, let me know. Otherwise, I can explain it a bit more. But basically, you see there's on the left side, we have like the block structure with the header and the block body. And then on the right side, we have some state. And those state thingies that we're going to look into soon, they have the form of a tree. So they are Merkle trees. I guess most people know what a Merkle tree is. But as a short reminder, it's like a data structure that makes it really efficient to compare state, and also makes it possible to have efficient proofs of a certain state. And it works by, you have some data blobs that you want to put into this tree, and basically it works by hashing those data blobs, and the hash of this data creates the leaf nodes of the Merkle tree. And then if you go up the tree, every node is basically the hash of all its children, and you do this until you're at the root of the tree, and that root is basically, it contains information about all the other trees, and if some little data blob changes down in the tree, then the root changes as well. So this is what we see here. This whole tree is basically stored in the header via the state root of the Merkle tree. Now we zoomed out a bit more. And we can see there's like those three parts that we talked about. The first one is about the accounts storage. Then we have like some storage for the transactions and some storage for the receipts. And let's look first at the account storage. It's called world state here. But it's the most fundamental thing, with that the state that the EVM can access. And exactly. Let's look a bit in how it works. So in the block header, there's the root of the world state trie. And this basically means that this is like the hashed version of a lot of data blobs, and these blobs are account states. So in Ethereum today, there are two kinds of accounts. There is like externally owned accounts. This is basically the stuff that you can control with your private key on your computer or on your ledger. And there are contract accounts. And again, this is like the model how it is currently working. There's talk about how to change it with like the whole account abstraction thingy. But for now, it works like this. So we have these accounts, and externally owned accounts, they basically only fill the nonce and the balance fields, and every time you send a transaction, the nonce is increased, and the balance is just like all the ether that you might own. For like contract accounts, this like code hash is also set to the hash of the smart contract bytecode that is actually stored for this account. And the important thing here is that like the nonce and the balance are mutable fields, so those can change in which each like state transition in the blockchain, but the code hash is actually an immutable field, and this is the reason why smart contracts can't be changed. So once this is deployed, even if you have a bug in your smart contract, you need to redeploy it, but you can't change the hash, and therefore you can't change the bytecode of a smart contract. So a smart contract also might have some data that it stores, and again, in this account state, we only have to store the root of like another Merkle tree, which stores the account storage. And how this storage exactly works, it's a bit like too deep for this talk. But yeah, you can imagine it's like some key value pairs with some data in a special way that makes the contract be able to access all this stuff. The next part that we talked about is the transactions. So the transactions are actually a part of the body. So light clients don't need all the transaction data. They actually only sync the headers. But we're going to come to this. They also store the root of this transaction trees. So you can imagine this like the body includes like a bunch of transactions, and this is the full transaction data. And they get put into a Merkle tree, and the root of this Merkle tree is stored in the header. So light clients can verify data when they get data from full nodes. The transactions itself, the underlying data is transaction blobs, and as you may know, there's like old school transactions, like the old transactions that one probably doesn't want to use anymore, but they're still supported. And then there's like more modern, like EIP 1559 type transactions. It's not really important, but they all get hashed, put into this Merkle tree, and stored in this transactions root in the block header. The same happens for the receipts. They are.
Quick question. So is the code of a smart contract itself stored somewhere on chain or in the state or not?
Actually not. It's stored in the database, and just the hash of it is stored. So you can verify that it's right, but you might have to request it. So for the receipt, it's the same. In order for light clients to work, there's the root of the receipts tree gets stored in the header, so the light client might not know what the receipts are for a certain block. But when they request the data from a full node, they can actually check that the data is correct. Which, it's kind of cool that they thought about it in the beginning of Ethereum to make it light client friendly. There's another cool thing to know about receipts. So events that are emitted by the blockchain, they are stored in the receipts. So often we want to do some filtering on like a big interval of blocks, and this is, you can imagine, it's like a sequential scan on a database. So we have to go through every block and filter out all the events that are matching. And if we would actually have to go down in this tree and like check every little event, then it would become like horribly inefficient. It already is inefficient to do this like sequential scan, and there's better solutions to do that. But there's a little optimization that people put into Ethereum, and this is basically we add like a Bloom filter in the header, and this combines all the indexed event fields get basically put in a Bloom filter. Some people might have heard about it. It's a probabilistic data structure, and basically you can have false positives, but you can't have false negatives. So that means if you see in this Bloom filter, you can check is something matching the signature, and if you receive a yes, then that means probably there's something included that matches that signature. But if you get a no, this is not included, then you know for sure. So basically that makes the sequential scan a bit faster by going through each block, looking at that thing. If it matches, then we have to go through the whole receipts list to check in detail. If not, then we can just skip to the next block. So now we looked at how these like three things work data structure-wise in Ethereum. And now I already mentioned that we have that there's a difference between full nodes and archive nodes. The important thing here is that usually people aren't interested in whatever old state. So as we see here, at like a certain block in the blockchain's history, there's always a link to the state root at that point. And in theory, you could query that, but often when you just want to estimate the gas price of a transaction or look at the state of a certain contract, you're only interested at the current state of the blockchain, not in the state like 1 year ago. So in order to optimize that, we can basically look which parts of the state trie aren't linked in the state tree anymore, and just remove them. And yeah, as I already told you, this usually removes the reduces the state by by a factor like 2 to 3. For transactions, we actually can't remove them. We might need them again to look at them, look at the history. And receipts also, they might be removable, but at least in Geth, they aren't. So in theory, they could be reproduced by either querying them or re-executing the transactions. But I guess also the amount of storage you could save is not really worth it, like removing them. So most of the state pruning actually happens in this world state try, that as they call it here. So sure.
Because you were also saying that in the EVM, I can only access the state tree, but not transactions and receipts.
Mm-hmm.
So transactions and receipts, I know them like as state transition history.
Mm-hmm.
So for the EVM itself, they are kind of irrelevant, right? You never need them in the future. I know they are interesting off-chain for users.
Mm-hmm. No, exactly. Like it's more like if you want to query them, and I think that's the main reason, it's not really worth it at the moment to prune them. But for the state transition, to check that, you just only need the current block, the current state try, and then you can check the state transition for the next block.
So I just didn't understand why then the receipts and transactions cannot be pruned in your opinion.
I think it's not really technical reason. I think it's more convenience reasons, that first people might want to query that stuff, like transactions. Okay, what are my transactions in the past? And it would be inconvenient and probably not really worth it compared to the state pruning of the state try to remove those. And the same with events. That at least, when I was doing stuff, like it was common to, okay, give me the events for the last year of that token or whatever. So in theory, you could remove it, but it would probably make it even more complicated to people to understand, what's a full node, or it's a full node that also has pruned events. So I really can only use it to, estimate transactions or look at the current state of things. Does it make sense?
Okay, but then it makes a difference what thing would potentially break the smart contracts, because removing transactions and receipts cannot break the smart contracts because they can only access the state.
Exactly.
It may break the user interface for the smart contracts. The user interface relies on events.
Yes. So as we saw, in the header, we always have this transactions route. So in theory, if we remove them, we could ask another full node, please give me this data. But then it would become more centralized, and it's a lot more pressure again on archive nodes and so on. So I guess this is some kind of trade-offs where people actually decide, okay, this storage savings are so small and it might be so convenient for people to have that data that they don't actually remove it at the moment. Maybe it comes when the blockchain grows another 5 years that people say, actually now we can save a couple of gigabytes by removing that stuff, and we remove it for everything that's older than 2 years or something like that. So now coming back to this L2 to L1 to L2 transition that I'm working on, and where we basically want to bring over our current state. How can we, in theory, do that? I see 2 ways. The first one is just do what every Ethereum client or Celo client does. We start at the Genesis block, we sync the whole chain, go basically through every state transition, check that they match what we see from the data we get from all the other nodes. And do that for a while. I think on Ethereum it takes at least a couple of days or weeks even nowadays. And get to the tip of the chain, and then we continue whatever we want to do. The other option that I'm working on is doing something that I found people call regenesis. So we basically do some kind of a snapshot of of the blockchain and remove all the history, but move the state trie into this new Genesis block. But first, let's look a bit at the trade-offs. So when we would want to sync this chain, that also means that we need to support all the historical versions or quirks of the protocol. So in Ethereum, it's I'm not actually sure how old it is now, but yeah, we need to support all the object formats, how the header looked like, and so on. We have to confirm to all the EVM behavior, how did certain bytecodes behave. We have to implement all of the hard forks that happened in between, even though we only want the chain to work in the current now and here. And we also have to support that for the unforeseeable feature. So the client is only getting more and more complex. And yeah, to give you a feeling of that, of course, I selected this because it shows that quite well. This is how an EVM interpreter is created in the Geth code base at the moment. So you see there's for all the hard fork that happened in the past and are about to happen, there's basically different instruction sets. And all over the Geth code base, there are those little if statements. If this hard fork is enabled, then do this. If not, do that. And yeah, you can imagine how that increases complexity for testing. From my experience, the stuff only gets worse, and you can't really remove all stuff ever because you need to support the sync process, and that means you need to run all of these code paths eventually. Another negative point is what I already said. The syncing process scales linearly with the block height, so the longer the chain gets, the longer it takes for the first sync, making it increasingly. Yes?
Sorry, a quick question. I realized I don't understand fully. So we have Silo blockchain with its own state, we have Ethereum, and now you're talking about syncing Ethereum from Ethereum Genesis in Silo, am I right?
Not really. So now I'm talking about the general, if we would something to do in Ethereum, then we would need to support all these different.
I just want to wrap my head around, okay, if you're migrating to an L2, if Silo becomes an L2, why do you care about all the Ethereum state?
I'm just taking it as example. I could have also shown some code snippet of Celo. It looks the same, just that some of the hard forks are called differently. But what I basically wanted to say, if you want to support syncing any chain, you need to support all the hard forks and all the code that was ever, all the protocols that were ever executed during the life of that chain.
This would be the Silo history.
Exactly. Okay. So from, I think 2017 or 2018, I'm not sure. I shouldn't.
Can you just not take the current Silo state and just basically declare it at genesis of Silo L2, that, okay, this is the initial state by definition?
That's where we're coming next.
Okay.
Good point. We're getting there. And so the syncing takes more and more time. So ideally, for people coming into the ecosystem, it gets more and more you start this node, and then 3 weeks later, you might be synced, or something happened in between, and you have to start from scratch. So it gets more and more hard, and people are more and more using centralized providers to do that kind of stuff instead of running their own nodes. So what we are thinking about is basically what you already said. We want to do a new Genesis block, but put the state we already have in there somehow. So of course, it's not that easy. And one of the big trade-offs would be that we lose all the historic transactions and all the historical events. They would be still queryable. We could keep the old nodes running before that event and query that stuff, but it would be a bit harder for developers to, they would have to do something to query that stuff. So quick intro, how a chain is created at the moment. Again, at the example of the Geth client. So on the right side, you see one of these Genesis configs. This is basically the file with which you can create a new chain. You see at the top, there's this config thingy where you can enable or disable certain hard forks. This is kind of an old example because it only includes the really bare bones stuff. then there's a lot of stuff which you don't really need to care about. And then here, this alloc field is quite interesting because that goes basically directly into the state trie that we looked at before. So this is the way in a Genesis config to set the state of certain accounts in the state trie. So here we see for this address like C2D7, this is going to be like an externally owned account, and here we just say under this account, please create like a balance or initialize it with a balance, and that also sets the nonce of this account. So once this chain is started, then the person that owns the private key for this account will have like a balance preset in this blockchain at the Genesis block. The second account here, this is going to be like a smart contract account. So we basically say, okay, it's not going to need a balance, but we also set like the code, which will put this like EVM bytecode into that account, or hash it, like store it somewhere and put the hash in this account state. And then we also set some storage for that account. So if we would then create a blockchain based on this config, which is like something like geth init genesis.json, we would create a new block, probably number 0. And yeah, if you would start it and not create no new blocks on top of that, you would have like at least this one smart contract and this one account in the blockchain. Now, the first obvious thing to think is easy. We can basically go through the whole state that we have, these like 190 gigabytes, and just put them into this JSON file, right? Like for every account that we have, we just write like a line in this in this config. So we could just say, okay, we get rid of all the old blocks and just go through every account in this giant tree, which is like 190 gigabytes. Yeah. And probably, I mean, this is like a bit more efficiently stored. So if we store it in the JSON, it's probably going to be like 500 gigabytes. I'm not sure. And then we would need to import that. I guess everything would break when we try to do that. So this is kind of the first idea, but we can do like it better. We can actually go at the database level and, yeah, hop over this export-import process on the way. Yeah, so I'm mostly working on the geth fork for this. So in geth, the data is actually stored in a key value database that is like underlying the whole blockchain. And so what we do there, we open this database and we're looking for the latest block in this database. And in this latest block, or in the header of the latest block, we can get the root of the state tree and store that, because this is the important part that we want to keep. We want to put that into our new Genesis file. And then we can actually go through the database, and there's going to be like these like 20 million blocks that I talked about in our database, and we can just remove them. So we just delete all the history. Have to be a bit careful that we don't delete too much data, but actually the blocks and the headers, we are not interested in them anymore. So we remove that stuff and then create by code a new block, whatever it's going to look like. We can set it up as we like. And importantly, we put this, the root of the state trie in there. So by then we have a new Genesis block that references the state that we had in the chain before, just that we removed all the history and removed like 20 million blocks. Now important to make clear is that everyone could do that. So everyone who has like a Celo node and is doing this migration, which is probably set at a certain point of time, can check this process. So it's like a tool that you can run, which is going to be enabled at a certain point in time, and everyone can verify that the new Genesis block that we are like putting online wherever is actually correct, and decide to not follow the chain if we try to build whatever backdoor in there, or change account state however we like. So this is verifiable, everyone can run it, and so nobody needs to trust us. But now we're running into a different problem. So now everyone who is running a Celo node can actually do this, but how do new people like that just want to sync with the network after this read Genesis event actually sync it? So The problem is now you can't go through the chain and apply all the transactions and actually get to the end state, but you need to somehow sync those like 190 gigabytes of data, which is not included in the chain. Or it is included, but it's not really available. So something that Optimism is working on for their superchain is basically that we extend the Genesis definition a bit. And this is like all the common stuff that's already in there, but we basically extend it by saying we also can give it a state hash. So we basically say we put a reference to that state tree in that we want to have, and the clients will accept it, saying, okay, this is the state I wanna have in the end. And for now, I just accept that I have a Genesis block and I have a reference to that hash, but I have to find out what the underlying data of this like giant Merkle tree actually is. And yeah, and then we can already use like existing protocols. So there's the ETH protocol, which actually nodes use in this P2P network of Ethereum to exchange blocks and headers and so on. And even better, the Snap protocol, which is especially optimized to sync state in Ethereum because it does like bigger chunks, so you have like less round trips, and it's in general a bit more efficient in doing that. So the procedure there would be someone wants to sync this chain. He downloads this Genesis file, which includes the state hash that everyone else can verify by using our migration tool. The client loads that, sees like, oh, I'm actually missing some state to verify the state hash, and then starts the Snap protocol to actually ask other full nodes in the network, please give me this data, and slowly rebuilds this state trie. Obviously, this whole process is not without downsides. So as I already said, we're gonna lose all the transaction and evade data, which is not nice, but yeah, you can still get it. Yeah, you can still run the nodes from before this regenesis event, which is not ideal, but it's still there. I mean, it's not lost, and yeah, it's just maybe a bit more inconvenient to access it. And building a seamless solution to access this might actually not worth it. I'm not really sure. But if you imagine like some ETH event filter query that goes over this regenesis event, you would need to split it. If you want to provide a seamless interface, you need to split it. You need to send both requests to the old nodes and the new nodes. You need to wait for their results, combine them again, and send them back to the user, which, yeah, it complicates stuff. To really make it work for every possible case is probably really hard, and I'm not sure if it's worth it. So that's something I want to discuss with you a bit later, or actually now, because so my feeling is that for transaction, I think this is like totally fine, but my questions for people working more on top of the blockchain is, do you still rely on events nowadays? Or is everyone using other like indexing solutions? The graph comes to mind. Is that something that you're working with? Would losing events from the chain history be something where you say like, okay, no way, this will never work, nobody will ever keep using that? Maybe, is anybody working in that kind of field and has an opinion on that? Okay.
We are only using indexers, actually, to be very honest. It's
okay.
Just, I'm trusting the graph, and it seems to be very good. So I don't care about the events on my own. But it's sometimes convenient on the client side to just pause for recent transactions and pause the events out of something. But this is only really true for something you put on it, right? So if you interact with a smart contract, you have to read the logs to see what happened right now. So it's your return value. But this is unrelated to your question. Actually.
Yeah, exactly. So that was as soon as you would execute something on the chain after this event, it would work as before, right? It would just be stuff that's before.
As a Web3 dApp developer, I would say. So just with the commercial background, I would say, I don't care about the blockchain itself. But this is not true for all the applications. It's just true for the ones that we have.
yeah, my feeling is the same. I mean, I spend so much time like finding problems in like event thinking code and all the things that could go wrong. But yeah, maybe people have different opinions. A different question that would be interesting, who is actually running their own blockchain nodes? Are people all using centralized providers to actually run blockchain nodes? And I'm not going to tell anyone, or is anyone like running their own nodes? I know it's a big hassle. Okay, yeah. I mean, it's awesome, but I feel like a lot of people don't want to do that because I have like horrible experiences, like data getting corrupted, and okay, the backups take forever, and yeah, my feeling is like I don't want to touch that stuff, which is horrible. But yeah, cool. Then yeah, I'm finished with the stuff I wanted to tell you. If there's any questions, would be happy to answer. Otherwise, yeah, I'm around to mingle later.
What's the current state of your migration? Have you already achieved that, or do you currently consider doing that?
So currently, I'm at the state where I actually generated a new block. I have imported it in another block, and I'm currently working on this, getting this snap sync to work. So I would say halfway. And yeah, we're currently at the state like where we're then discussing, okay, will people actually accept that when they lose all their events? Do we actually have to do something more complicated? I mean, then we could think about stuff like rewriting history if we want to get rid of all the other stuff, the historic things that are lying around. But yeah, I hope that we can find an argument that this is actually working good enough for people to accept it, to avoid spending more time on this. Yes?
Can you connect a bit to these migration tools? If I understand correctly, you're going to reach some off-chain consensus about the snapshot height at which one can calculate the state.
Mm-hmm.
And then you're going to use your tool to calculate the new state root and, I guess, load DL2.
Mm-hmm.
And everybody, all the validators of your I1 will kind of start. Oh, sorry, yes. So I will repeat then from the start. Mm-hmm. So just on this migration that you were talking about, if you can comment on how can you do this in a decentralized way? Because if I understand correctly, you're going to reach consensus about the snapshot height, calculate the state root with your tool, and then validators will start, creating blocks on the L2 immediately, if I understand correctly, and then validate a posteriori that the state root that was like written in the regenesis block is actually correct. And then my question maybe is, how long does it take for your tool to actually calculate the state root? And would it make sense to rather have validators of the L1 each independently calculate the regenesis block and then move on to the L2 once there is consensus on that?
Yeah, a great question. So like the first thing you realized, which is important, to actually do this migration, we need to stop the chain, which is not something that, I should have maybe said that, but actually we need to stop. We we ask for a hard fork at this block, then actually all the nodes stop creating new blocks. Everyone needs to run this migration tool. Might be faster or slower for people depending on their machine, and then we need to start it somehow synchronized again. So this is all like really much in discussion. So maybe an easier way is to start with a centralized sequencer in the beginning, say, hey, for this process, we do it, then we start it again, and then afterwards we have a second hard fork where we bring back decentralized sequencing, something like that. But this is something which is a bit like further on the roadmap. For now, I try to get this working with a centralized sequencer, which would basically allow me to get rid of that whole problem. It would be, okay, one node does it, then the sequencer starts again, and everyone else can verify if the block the sequencer uses as the new Genesis block is actually correct.
Thanks. And maybe just to, if there are no other questions, to continue on that, in principle, do you really have to stop the chain? I mean, I guess once you fix the block at which you want to do the snapshot, the underlying chain the legacy chain, if you want, could continue forging, and if not enough validators, I guess, according to some rules.
Sure, that's always the option, right? That people say like, oh, I don't want to do this, I disagree with becoming an L2, I just continue the chain. That's possible. But if you would continue and you want to follow on the L2, then every block that's created after the fork date would be lost. So all the transactions that you send on the old chain, which is discontinued, would need to be reapplied to the other chain.
Right, but just to conclude my last question, which is actually where I wanted to get at, I was always curious, in these situations, you have a proof of stake system, right?
Mm-hmm.
So you have some sort of not in a stake problem, but actually between the L2 and the legacy chain, in the sense that if I'm validator, why should I stop forging on the legacy chain? Why can't I continue it forever and ever as a fork, if you want? Like a Silo Classic?
Yeah, I mean, you could do that. I mean, I hope that people agree that there's enough benefits with actually getting this like additional security from becoming an L2, like the additional benefits of being closer to the Ethereum Foundation, having easier bridging, that this actually convinces the validators to join that. But this is actually a task we have to do to convince them.
But you could do both, right? If it's proof of work, you can't because you have to split your resources, but...
Yeah. Cool, any more questions? Nice, then thanks for attending.
Should I start? Yeah. Okay. This is on, so I guess so. Hello. How are you doing? Good. Cool. So I'm Pedro. I'm a DevRel engineer for Aztec cLabs. You probably know what Noir is, but still, we're going to start with the basics of Noir, what it is, and so on. I'm very glad to be here. I was here last year. It was a great conference, and I'm very glad to be here as a speaker this year. So this workshop will consist basically in 4 chapters. But first of all, I'm going to present a little presentation before the workshop. The workshop is meant to be interactive, so you go and play with your own machines. So let's see how that goes. First, I'm going to talk about ZK. What is ZK? You probably know if you're here, but still, this is a layer 1, let's say, a layer 1 conference. I'm going to talk about Noir. Why are we doing this? What is Noir? What's its purpose? I'm going to talk about the project that we're going to build here. And finally, yeah, let's finally hack something, try to do something with this. So we know that zero-knowledge proofs are powerful. You can prove things without saying what you're proving. And this is huge for not only blockchain, but pretty much anything you can think of that you can keep some privacy. But with great power, usually comes universal commitments, basically. And this is one of the problems that I can't understand that. Some people do, I don't. And so that's basically the problem, and that's why you need a usable universal ZK-DSL, so zero-knowledge domain-specific language. Basically, something that can run your zero-knowledge proofs. And for that, we need a syntax. And we like Rust, so we basically choose Rust to copy, and literally copy the syntax of Rust. So if you try to find the difference between Rust and Noir, you will find some, but not a lot of them. Especially if you write a Noir circuit and then you compare it with whatever Rust, you're not going to find a lot of differences. And so, for example, this is an example of a Noir program. And if you try to spot the difference, yeah, that's kind of on me, right? Because one is blue and another one. But yeah, they are literally the same. What we want is for you to write code and not circuits. So you write the code, and then it will compile with something that you don't need to understand. It's highly abstracted. Once you start scratching the surface, it's completely different, but the syntax, at least, it's just the same. And this allows for both things that happen for beginners and also for pros. Basically, people that I just want this ECDSA signature verification. I don't need to write the whole thing. Okay, Noir has this module. I can just use it. I don't need to write the whole thing, and I don't need to think that ZK is just for me. ZK is for everyone, and we need this to be usable for everyone. And so our build plan is going to be basically how to learn Noir in an afternoon, or I won't get your money back, sorry. Yeah, that was a bit of an oversell. So we have like what I call like 3 or 4 chapters. Most probably we're going to only have time for 3. But basically, I'm going to introduce what is Nargo, what is the Noir syntax, how to write tests, how to generate proofs, and then how to import some and use some standard library hash functions, how to use another libraries, external libraries, how to generate smart contracts, and how to deploy and verify, and how to wrap them in your own smart contracts so you can use them for your games or for DeFi apps, whatever you are building. Yeah, some things will not work. Yeah, like verifying proofs on chain. Sometimes it's a bit tricky, so bear with me if it doesn't work. That's just how it goes. It's live demo. You can break it anytime. yeah, so let's eventually go and do something. So I'm gonna ask you. So you maybe pick your camera, and maybe at least the workshop resources, they could be useful for you if you don't trust me, and you shouldn't. So yeah, but you don't absolutely need these workshop resources. It's just because there are some links in there that you can copy and paste to start running Noir up and Nargo on your own machine. So yeah, it's useful. I'll stop when I don't see phones in the air. Okay. Yeah, it's a GitHub. It's a GitHub link, so you can just go on noir-lang/noir in an afternoon with hyphens, and yeah, there you get GitHub repo. You don't need to clone the repo. Sorry?
Noir-lang slice?
Yeah, Noir-lang, yeah.
Slice what?
Noir in an afternoon. Yeah. Cool. So no phones in the air. So cool. I'm gonna sit down so I can actually type something. And yeah, so basically it's a Noir in an afternoon. Yeah, this is the repo. Yeah, cool. I'm going to start a new app, new terminal. I suggest that you follow along. If I'm going too fast, please tell me. Just shout. And our objective is, imagine you're like Brad Pitt and you are an owner of a Fight Club. He wasn't the owner, right? I don't remember if he was. Was Brad Pitt the owner of the Fight Club? Yeah. Yeah. Yeah, he started. Yeah. So imagine you're Brad Pitt. Probably not as pretty as Brad Pitt, but imagine you are one, and you are the owner of a Fight Club, and you want to only enter someone that knows the password to enter the Fight Club, and also you want to only allow people that are at least 18 years of age. You don't allow minors, obviously, in your Fight Club, right? So this is basically our premise here. Let's start with installing Noir up. So yeah, sorry. How do I do that? Oh, here. Better? Yeah, okay, cool. So you should install Noir up first. If you're familiar with, and you do that, you do that with this line on the repo. You just copy and paste it. You can trust me. Trust me, bro. And basically, if you're familiar with Rust app or Foundry app, that's basically a very handy CLI tool you can use to install Foundry or install Rust. And this is the same for Noir. It will install Nargo. You see, cargo, Nargo, yeah, kind of the same. And so you install Noir up, you run this command line. I'm going to do that as well. Just copy and paste it. It will download it, and you probably should quit your terminal and start a new one because of the path variable. And then you can just go and run Noir up, and that's it. And he's gonna install Nargo. It will probably take a little bit more time because it will install the init SRS. Can take a little bit. And then when you're finished, you can run Nargo version just to be sure that it's on your path. And this will get you, hopefully, 0.10.3. And I'm hoping that this version works fine. Because, yeah, sometimes you have breaking changes. Yeah. Cool. So I'm assuming that's okay? Everyone has it? Or at least the ones that are following this? Cool. So in that case, let's start with Nargo new, and let's call it Fight Club. Nargo new Fight Club. And this basically creates a new project in this folder. And let's just see what it is. It's very simple. It just has an argo.toml with a bunch of things that you need to specify, like name, type, whatever, and then you have a basic circuit. This circuit is really, really simple. Basically, you provide 2 variables. Privacy is normal, right? So you only say what you need to be public. Everything else is private, and that's how it should be. And so that's the way you just say what is public, and then you just keep everything else is going to be private. And this circuit just checks that one value is different from the other one. So for example, if you input 1 and 2, they are obviously different. So you are proving that you know a value, you know the value x, such as x is different from y. Okay? This is probably the most basic circuit you can write. You write it just like Rust with fn syntax. You need to provide a main function because that's like the point of. Sorry. Yeah.
Why do you have Noir as a code colors?
Oh, okay. You mean the syntax highlighting?
Yes.
Yeah, it's an extension you can install. Noir. That's a very good question. Noir language port, so you can install this. But for now, it should be good. I mean, you can install it. It's very, very easy. But yeah, good question. So you have the variables you just declare just like you would do in your Rust code. If you have an array, the size needs to be known as compile size. So you make just an array and they say how many values you have. That's just like that for every ZK language. You need to know stuff at compile time. And you declare whether those are to be public or private. In this case, for example, it could be public. This wouldn't make sense, right, if you're proving things that everyone knows. But you can have like circuits that prove things that no one knows and have 2 private variables. That's okay. For return values, you could do it like this, but this doesn't make much sense. I mean, how can you return something if it's not public? It needs to be public. Okay, so it will complain if you don't put it public. Because the way it behaves, it's just like if it would say return pub field. And then if you provide the return value, it will just say, let's say that you have a z value, let's see, is x plus y, for example. It will just assert that z is different from the return. But this is, it's not, okay, not return because it doesn't work, but yeah. This is not so cool, right? So that's why they implemented like something that's actually called return. But this is important because if you're providing an input to your circuit, you also need to provide the return value. So you need to kind of calculate what's the return value and then send it along with the circuit. But yeah, that's basically how it works. Another thing that we should say, it's just like in Rust, you have mutable variables. So let's say z, it's x plus y. You just can't go and say z then is z plus 1. You can't do this. You need to declare it as mutable, like mutable z. Okay, so there's a yeah, just like in Rust, I guess. You also have like shorthand operators. So in this case, we have z equals 0, z plus 1. You can just have it like z z plus equal 1. You can have like the shorthand operators. You also have some control loop, control flow things like loops. So you do it just like in Rust. You would say like for I in, just like it says like thanks good GitHub, just like that. It's just you can do it a loop, but you also need to know the size of the loop in the compile time. And the reason why you need to do this is because Noir will then unroll your roll loop, so it will be huge. And so you need to know, because it needs to know how many loops it needs to unroll. You also have some like if-else statements. So you can say like, if x equals, in this case x is an array, but yeah, if x at 1 equals whatever, you can just do else, just like with Rust, right? You can do the same thing. You can check also the documentation here, just like in the links that I've shown in the beginning, if you need to know basically all the language concepts that I'm introducing here. That's why I'm not going to deep dive into this. Then there's the assert keyword that you've already met, assert x different from y. This is the original circuit. And basically, this is, it will basically say, yeah, this circuit will prove, or it will verify if this is true. And so, yeah, this was known as constraint in the previous versions of Noir if you tried it. Now it's assert, because it's an assertion. Another thing that's very useful, it's structs. So you can have like structs person, and you can have like an age, that will be like a field. I'm gonna talk about fields in a bit. Field, for example, and then you can initialize this let z is a person, and then initialize it with age is x, for example. And you can do all kinds of things that you usually do with structs. And in the latest versions, if you try to use the nightly versions, you can also, there's some support for implementations as well. So you can have like impl traits, basically have traits for structs like you would do in Rust. Yeah, but it's just in pre-release versions, so don't expect them to be any kind of stable just of now. Tests, basically, this is a test. Usually there would be, I don't know why there isn't, but there would be some code lines here, so you can run tests, run test. It will run that test. But you can run these tests, for example, just to go back, assert x different from y, x different from y. You can run argo test, and it will, fight club. And run argo test, and it will run this test. So yeah, if you make it equal, it will fail because it's assertion basically will fail. That's it. So that's how we run tests. One thing that would be really cool to have is tests that are supposed to fail, but that will come at some time. Cool, and that's basically just a little primer on Noir and the circuits. So I have some notes here because, yeah. Any questions so far?
How can you run it?
Oh,
you can run the test, but how can you run the?
Yeah, sorry, I forgot that part. Yeah, you should run you should get to proof, right? Otherwise, it doesn't mean anything. It's very easy. You just go and run argo proof, and you need to run argo check first because you need like a prover on the verifier. Here, like prover, verifier, and as you can see, like the verifier doesn't know x, doesn't need to know, shouldn't know actually. So let's put some values here, like 1 and 2, and then you can run argo proof, and this can take a little bit. In this case, it shouldn't take. Yeah, it's kind of fast, and it automatically will populate your verifier. And you see, one of the problems is like, yeah, it will pad with 32 bytes. So that's something that we need to improve. But yeah, basically you can then run argo verify and you get your proof. So you can do this proof. It's kind of not so human readable. But yeah, this is a proof. You can basically. The witnesses, if you want the witness, you go and run an argo executes. It will execute your witness. Yeah, if you want the specific one, the witness. I think you need to get get it. Yeah, here. If you want just the witness, you have it here. Sorry? Yeah, it's when you X is private, so you only provide the Y, which is the public part. Yeah. So the verifier only needs to know the Y and then have the proof and the witness, and that's it basically.
I am also. Isn't it supposed to be a snark so it's succinct because the proof is like a lot of bytes?
Yeah, I think this is okay. Yeah, it's fairly succinct, I guess. I don't know. I guess it depends on what. Yeah. That's succinct, right? I would. Yeah, I don't like Starks. They are usually much bigger. So. Yeah, I mean, this is enough that you can send in an Ethereum transaction, which is the goal so far. Yeah.
I was expecting more like a hash.
No, yeah. Not yet. Cool. So let's explore a little bit this. Let's explore the standard library. So basically, just gonna check my circuit. So. So if you go to noirlang.org, you get the documentation, and you get Noir standard library. You have some stuff here. You have some hash methods, some scalar multiplication, signatures. ECDSA signature verification is a big one. It's really cool. And you have also some Merkle tree. You can compute Merkle trees and verify this like proof of inclusion in Merkle trees, stuff like that. I'm going to just focus on the basics, which is just hashes, basically. And I'm going to pick, you have some hashes here. If there are other hashes that you know how to implement and you want to contribute, please feel free. We have a grants program as well. So if you find some interesting hash to add, yeah, just talk to me in the end. I'm just going to basically talk about one of the hashes, which would be Poseidon. So Poseidon is a very friendly hash, a ZK friendly hash. So it's a hash it's okay to approve on your ZK circuit. It doesn't take too much, like a lot of gates, a lot of circuit size. And one way you can know that is just by running argo info. And it will get you the number of A0 opcodes and the backend circuit size. So I'm going to go on a tangent here about what is this A0 thing. So when you run an argo program, what you actually do is just compile it to another intermediate language called A0, Abstract Circuit Intermediate Representation. And basically, you feed that into your different backend. So you can have, like, for example, Noir outputting A0, and then you have at A0 feed it to one prover or to other prover. You can feed it to, in this case, we only have Halo 2 backend and Baratzenberg backend, which is the default. But you could potentially like feed it to a Plonky 2 backend or whatever. You can do all kinds of nice things. So in this case, it will tell you how many opcodes do you have in your intermediate representation, and then what actually matters, which is how big is it your circuit in your backend, in the backend that you chose, which in the default is Baratzenberg. And so yeah, it's fairly small circuits as you can imagine. And so one way of knowing which hashes are more friendly is just by trying to run them. Again, you don't need to know how they are implemented. I know that Poseidon is more efficient for ZK than Ketchak, for example. I don't know why. I just know it, but I could just go and try it and see, oh, this circuit is more efficient than the other. So it won't stop you if you don't understand any of the cryptography. And so, yeah, let's start with Poseidon and implement our fight club finally. So let's go and use the dependency standard library. And then I copied here how it should supposed to be called. And so let's define a struct. This struct is going to be a person, which is a fighter. And I just want to know its age. Actually, I don't need the whole struct. I'm just here just to show you that you can use structs. And you can also have like globals. Global, in this case, global minimum age. And I'm going to call it, it's a field. So I'm going to say the minimum age is 18. Because we're in Europe, I guess in the US it would be 21, I suppose. I don't know. Sometimes it's 21. I don't. So yeah, the global is basically just as it says, it's a global to our whole program. And so in my what I want to check, I want to check the age and I want to check the password. So I want age to be kept private. So it's going to be a field. A field is basically a big integer, okay? I'm probably wrong at many levels here, but that's how I think about it. And no one at Aztec has told me that it's completely wrong, so it's okay. So you can think of it as an integer. You can make some arithmetic things with it. You can make some comparisons with it, and it's basically just a point in a finite field.
We are going to use fields everywhere?
Sometimes we would use weights. We're going to be using those, and yeah. So just for now, it's fields for Poseidon, and the next example will be with uint. So there's a password as well for entering the Fight Club, and it's just we don't have support. Like we have some support for strings, but it's not great. So I'm just gonna basically just feed it 5 integers, and that's the password. and we also have a password hash. And so this is basically the hash that everyone knows. So no one knows what the password is, but everyone knows what's the hash of the password. You want to prove that you know what's the password without saying which one it is. That's the beauty. And so my people that will join my Fight Club, I can tell them the password. They know the password. I can prove at entrance that they know the password. They can send to me the proof that they know the password, but they never tell me what is the password. And they will send me proof that they are of a certain age. Just like I start here, okay, cool. Just like I start here, I'm gonna say that the hash is the Poseidon with this curve and the hash of 5 of my password. So I'm gonna pass the password, the array that I've defined here, and I'm gonna assert that the hash that I computed in my circuit is just the same as the password hash that the user has provided. And then I have a person. Yeah, that's correct. Thank you, GitHub. And it says like a person has a certain age, basically. And then I can check that person age is higher than the minimum age. It will complain, but let's just try and run this. I'm gonna get like the main. This is gonna be 18. The password, I have it somewhere. Maybe not the other. No, it's not here. Sorry. I think this one. Let's just say password is 1, 2. Not sure this is gonna work because I have a different one here in my private repo. And this is the Poseidon hash of that. If you notice in the other repo, you have some utils folder with a Poseidon and Ketchak file. That's basically, if you don't trust me, that this is the hash of that. You can run it. So let's try and get Nargo test. And it failed. And oh yeah, 1, 2, 3, 4, 2, 3, 4, or just maybe just go and say hash2 password. Nargo test. Yeah, again it says that fields cannot be compared. So that's in this case you're just gonna say you just compare with as you wait. And the reason is, I guess they cannot wrap around, so you just can't compare them directly. You need to range check them, and that's why I'm casting this as you wait. It could be U32 or whatever, just the smallest one for this case. So in this case, the Nargo test will hopefully pass. Okay, cool. So it knows that my Poseidon hash that I calculated here is just the same as my password hash that everyone knows. Okay? So I was gonna give you an example about the Poseidon, about the Ketchak, but I won't have time. So let's just go and run Nargo info to know what's the size of the circuit. And you see the AC codes, and then we have the backend circuit size. If you do Ketchak, it's gonna increase massively, like 10 times or more. Because Ketchak is a nice hash, but it's not so ZK friendly, and so it uses a lot more resources. But yeah, if you want to try it, sure, just go on the documentation and check the Ketchak, and just use this. It uses unsigned integers as well. So we need to cast them or just provide them differently. So yeah, this is an example implementation. Cool, and you will see that backend size will increase massively.
So a quick question: when you have #2 and #5, is this did you define every single function in the library, or is it like there's some magic that?
Yeah, I think there are like. It's like magic numbers, like #2, #3, #4, #5.
So, like it will build a circuit based on the name of the function.
Yes, yeah. You need to have that beforehand. Maybe there's a better way of doing it. It doesn't seem doesn't seem great, but I don't understand why. So I can say if it can be optimized. I have no idea. But yeah, good question. So any other questions? Sorry?
Would be short circuited, is there something like a break?
No. What there is unconstrained functions, and those are very interesting. But I would spend the rest of the time talking about them. But you could basically use unconstrained functions to break to return early. But other than that, no. It will unroll the whole loop and execute the whole loop, just as much as if you have an if and an else case, it will basically run both cases and then just choose the path that it uses, but it will run the whole circuit anyway. So if you have like huge if and huge else, it will run both of them. Again, it's not perfect. Cool. So let's just prove something. Just basically copy this hash and just put here in age, right? Age 18, and then password 1, 2, and then password hash. Is this hash? I think it needs to be in double quotes. Okay, so I'm gonna go and run Nargo proof to get a proof. Because we're going to use it later. As you see, it will download the init. This is basically the phase 1. So if you're familiar with zero-knowledge proofs, you have to have a ceremony to have your circuits. In this case, because we're using blockish constraints, you only have one ceremony, and that works for all your circuits. And it's different from, for example, Graph 16, where you have to have a different ceremony for each of your circuits, which is not cool. So for our smart contract, we're going to use Foundry. So I don't know if you use Foundry, but if you don't, I invite you, because it's a great tool. So I invite you to just go and run this little Foundry command. It just like Noir app, it will install Foundry, all the Foundry tools, which is, I think are, it will install Foundry app, and then you call Foundry app. It will install the Forge, Cast, Anvil, and Chisel. We're going to just use Forge and Cast and Anvil, not Chisel. I don't even know what Chisel does. Yeah, cool. First of all, before I forget, I'm going to run an Anvil network. What is the Anvil network? It's just a blockchain that runs on your machine. And this is very useful. And I'm going to pick up a private key here, just first one. It has a bunch of money in there, so I can use it, no problem. It's very easy. Just going to put it here because I may need it later.
Anvil, right?
Yeah, I run, sorry, Anvil, yeah. And I'm going to start a new, I'm going to leave this running because I'm going to deploy on it. So I'm starting a new terminal. And I have to cd into my directory, and I'm going to say nargo code gen verifier. And this will generate a smart contract that has your verification key and basically can verify your smart contract, your zero knowledge proof. And you can deploy it very easily, and that's what we're going to be doing. So those of you that are familiar with Solidity and Foundry, you're not going to find this you don't find this difficult. It's very simple. It's just like another smart contract that you can use in your own projects. So yeah, this is written from someone way more smarter than me. And so I don't know what this is, right? This is, yeah. I admire like people that have wrote this. But the relevant function is verify function. And I'm going to actually copy this function signature because it will be useful later on. And so this is basically what you're going to call to verify your proof. Copying this. Okay, cool. So then I'm going to create a Forge in it, a Forge project, Foundry project here. I'm going to pass the force because it wants a new folder, and I don't want it. I'm lazy. And I'm so lazy that I'm going to delete the test folder because, right, who needs tests? I'm also going to clean up this a little bit, probably going to put like the contracts in the same place so they are easy to refer to one another. And yeah, that's it, basically. So now we can develop our smart contract just like we usually do. I'm going to import my verifier from here, import, it's in the same folder, that's why I put it there, plonk vk, and that's it. I have my What do you want? File import. Yeah, that's all. Cool, thank you. So yeah, I'm gonna remove all of this. I don't care. I'm gonna write a constructor. So basically, you are used to do this. I'm just gonna say ultra verifier, public verifier. Even GitHub knows. Constructor. Yeah, that could be. But okay. That's it. Not address, that's why. Ultra verifier, and here is my constructor. So if you are probably used to this, you have your verifier here. You are passing it to your contract. So when we deploy this, we're gonna need it basically. We're gonna pass the address here. And one thing, yeah, then we're not gonna use this. So let's say that you wanna call the increment function and you're gonna say the proof is gonna be, I think it's bytes. Let me just check the function signature. Yeah, bytes, call data, proof, and yeah, this is what I'm gonna be using, and I'm saying verifier, verify, proof, and then the public inputs. Yeah, public inputs. I'm gonna take care of that. So public inputs, maybe it will be cool. I don't know how I did it in my reference example, but I think I just pass it in my constructor. Yeah, basically. So yeah, bytes 32, password hash, because everyone knows the hash that can be on your smart contract. Probably you want to pass it every time. Yeah, to save some gas, to not store it on the contract, or maybe you want to store it on the contract because anyone can pass whatever password. Yeah.
It's likely not an array.
Sorry?
It's just the bytes 32, I guess, not a bytes 32 array.
Yeah, this one?
Yeah, I think so. At the moment, it's an array of bytes 32.
Yeah, it's an array of 32 bytes string, 32 bytes. Yeah.
Bytes 32 is one.
Yeah, it's just a hash, so there should fit in 32 bytes.
Exactly, it's just a bytes 32 type.
You don't need a
hash is bytes 32.
Okay.
Maybe the API requires that, but yeah, it should not be necessary.
Yeah, I mean, I'm gonna just pass it here, so that's why I'm saying, yeah.
But those are public inputs.
Yeah.
It's called data, okay.
Yeah. So yeah, I know this works, so cool. So this password hash, and I'm gonna pass it in the constructor just like I did. So it has to be memory because it's bytes. It's a byte 32 memory. Yeah. Sorry, password hash. Yeah, it's confusing. Because it's a public input, so I call it password hash, but it's the public inputs actually. So you're gonna see how it, basically. So yeah, basically now I'm gonna password hash. This is the mess that you're referring to. So hopefully this will work. Let me just check if I'm missing something. Probably I am. And go say forge, create. I'm gonna say the private key that I stored in there. Okay, sorry. Oh, sorry. First of all, I need to deploy the verifier. So I say contracts, not reference. It's Fight Club. Plonk VK because I need to deploy the VK. Usually you would do this in a script, but I'm too lazy, so I'm just gonna say ultra verifier, and this hopefully will deploy, compile, and deploy. Okay, so I have my verifier contract here. This is the address, and so now I can basically pass this along with the public inputs into my contract. And so, yeah, I'm gonna say forge, create, private key, it's the same, and say Fight Club, not Plonk VK, it's gonna be counter, right? It's counter.sol, counter. Please let me know if I make any mistake or typo. Constructor args, I'm gonna pass it expects the address and it expects the public inputs. So basically, I'm gonna go here. It's already here. I know what's the password hash. So I don't know if it's the same here in my test. Yeah, it is, right? Yeah, of course it is. It was auto-generated. So I go, I'm passing it. Just let me show. Yeah, it's an array, so I need to pass it here. And okay, cool. So now I have my counter contract here, and so this is the verifier. And this is the counter. And now I can call that contract and say cast call. I'm going to call this contract. I'm going to say what the function is. The function is not verify. It's increment, right? Increment, and say here, and public, yeah. And my proof. So proof, I have it here, right? Where is it? Yeah, I have it here, my proof. So yeah, it's an hexadecimal string, so I need to tell him that. Here's my proof, so it's succinct, right? It's sorry? Yeah, it fits in the call data. And so yeah, I'll take this 0x as okay, right? It means that it didn't revert. So it executed the function correctly. So basically, you can use this verify. You can use it in a modifier, for example, to safeguard your Oh, good one. It's a view function. No, it's not. No, it's it. Yeah, I did increment. So I don't know. It's probably this one, the latest one, last one. Yeah. It's less than I imagined actually. I was expecting like 400K. It's not cheap, right? But it's a start. So, and that's basically it. Just not in an afternoon. The fourth chapter will be how to basically do this proof verification and smart contract calls in your browser. But I will not have time. I'll leave these 4 minutes for questions if you have. If not, I'll just give you 4 minutes back, 3 minutes back.
So did you change the commitment scheme?
No. No, it's this is what we have.
Speaking of which, when was the what's it called, the ceremony? I keep forgetting the name.
Yeah, the SRS, the Ignite.
Was it generated through a ceremony, or is it just a
It was generated via ceremony, but it was a long time ago, before ZK Money was deployed in production. So I guess 2017, no, later, 2019 maybe. Yes, there is a command line for that if I'm not mistaken. Yeah, you can yeah, but it's okay, right? It was distributed. You can trust it. Yeah. Any other questions? Yeah, because it calls the function signature directly, so it doesn't. Yeah, that's why it says that it's unused. Yeah, but it's a view function which is useful. You could use it. Depending on what you're trying to do, you could not use gas actually, which is always useful if you want to just hit the node.
I have kind of an advanced question that I don't know if that's possible with Noir or not. Is it possible to do a kind of Merkle tree of the state of a contract? So you can check the state of that contract that it's in another chain from an L2 or something like that?
Yes, I guess yes. You can just use a Merkle tree and depend on a Merkle tree. Just go and add it, and then nullify when it's found in another L2. Yeah, so like a ZK bridge, I suppose.
Which will be the path to work through that? Because I think that it's kind of way difficult, but which should be the resources that I should use in order to do something like that? The documentation. Is there something else that any other repo that you can think of that already did something like that?
No.
What I'm interested is, if I have these tokens on mainnet,
Mm-hmm.
I want to know from Optimism that I have these tokens, the balance of the another chain.
Yeah, you could basically commit to your tokens on your L1 and then verify on L2 that you have those tokens on L1, and then nullify them so that they don't get proven twice, like claim it twice on your L2. I guess so. I would have to think about it, but I guess that's one thing. But now, if you trust then there is problem of reorgs and everything that you could have to be aware of. L1 reorgs, L2 rewinds. So that could be a problem.
Well, you could commit that it is like a lot of blocks before, so and it has already been finalized. So the reorgs are not a thing.
I guess you could. Yeah, I guess you could do something like that.
I think that the use case is very important because
of course
you can say I have these tokens at this moment in time anywhere.
Yes.
So it can be used for voting on any other chain.
Yes. I mean, you could use these as like storage proofs, which is something that we're working with. Like we had a research sprint to basically have storage proofs. So the proof that you know a CryptoPunk, that you own a CryptoPunk without saying who you are or which CryptoPunk you have.
That's what I'm interested in. Is there any resource that I can use?
Yeah, you should join the Discord. Just come back. I've put that in the first link actually. The Noir Discord. You should, if you're interested in Noir, just join the Noir Discord and make your question there because we have some resources that you can use, like for this kind of Ethereum storage proofs, but they are not cheap. Because the Merkle tree, like the state tree, the world state in Ethereum, it takes a lot of Keccak hashes, and as I said, they are not very zk friendly. So you need recursion basically, because otherwise it would not fit in your WASM 4 gig limit.
What does it mean that it is not cheap? To compute?
To compute is okay, you can do it on a laptop, but to verify, it's not. I mean, you can do it in a laptop if you use a recursion. And you can verify it on chain as well if you use recursion. But that was a problem that we hit when we accepted the challenge of Ethereum storage proofs. So we're like, it's cool, just verify this number of hashes. Each hash should be this, and we were completely wrong. And then we had to start developing more like ultraplonk, implementation of ultraplonk, so we could use recursion and to make it cheaper. And we have it running, but it's really not like you don't get easily with nice bindings, GS bindings or anything. You don't get.
If I am running the verification on an L2, it's going to be cheaper. So probably.
As long as it fits your block, like your gas limit, and you can pay it. I guess it's okay. I don't even know how much. I mean. This amount of gas, how much money is this? But it's probably a lot. I don't know what. Yeah, so that's not cheap. Yeah, it's almost 300K. Yeah.
Yeah, okay. So like the maximum is 30 million.
Yeah, so it's not cheap in any way. But it's okay again if you're gonna do it in an L2 or something, because on Ethereum it's not. That's really unbearable. Yeah.
It's not cheap for voting, for sure.
Yeah.
To prove that you have tokens, it's not cheap.
Yeah. So we have some examples. If you go on the Noir, you have Noir Starter, which is basically a boilerplate for you to start with, and you have also Noir examples, with some examples that the DevRel team has put together. One of them is voting, another one is an airdrop, a stealth airdrop, which is not safe, okay, because of ECDSA signature malleability. But it's an example. I think it's here that says not safe. Yeah, this is unsafe. Yeah. Cool. Another thing, Noir is going to be used for Aztec smart contracts, so that's a pretty good reason to start learning Noir, basically, because that's the language you're going to use to the Aztec chain. And I'll be glad to talk about Aztec Chain later on because I'm over time here. Yes.
But that's not including any chain verification. It's just verifying the proof and the stuff.
Yeah, off chain. Yeah, yeah. But it's really cool. Yeah.
Unless more chain runs into this composite wisdom and runs into the browser.
Yeah. It's pretty complicated, but they are really good. Yeah.
Might have some more basic understanding issues.
Mm-hmm.
We provided the proof to the smart contract.
Mm-hmm.
And the smart contract does not know what circuit this proof belongs to. It just proves that these inputs and this proof correspond to each other.
Yeah, when you generate a smart contract, it is specific to that circuit. So this Plonk VK, so basically the contract that we generate with Nargo code gen verifier, it's specific to that circuit. So it contains the verification key. Yeah, the verification key. And so if you change the circuit and then run with other values, it will not verify because it says, yeah, you're trying to use a different, so this verification key doesn't work for that circuit. So every time you make a change to the circuit, you need to generate a new smart contract and redeploy it. Hope that was useful.
And what's the size of that smart contract?
What the size? We can try to get the So yeah, I only have 2 transactions here, so I would say that this is probably the two contracts that we deployed. So yeah, this is the size. In any case, this was the first one, so this is the size. Not small. None of this is cheap. You don't get privacy. You don't get cheap privacy. Until we get to Aztec Chain. Cool. Yeah, we're gonna. 4 minutes? Okay, cool, thank you. Yeah.
Can I generate the verifier in Rust?
Good question. Yeah, you could. Yeah, I could. Maybe using like FFI or something. Probably yes. Yeah, Nargo test only. Yeah, it only runs like the code. Literally, so yeah, I guess so. I guess you could do that.
The idea is that there are blockchains that have Rust as the programming language, so Noir and Solana. If I can just plug it in.
Oh, you mean like the smart contract, the verifier smart contract in Rust? Yeah. Yes, you can, but we don't have it yet. But if you're interested in building a verifier smart contract, please reach out because this is something that we really want. We are not like Ethereum. Maximalists, we are okay with any other L1. So if you're like, oh, I wanna verify on Solana, be my guest. Unfortunately, we only have Solidity verifier contracts. But yeah, if you have the knowledge and the will, we would be glad to talk with you to have this done. Yeah, and for Solana or any other chain, basically. Cool. I guess this is it, right? No other questions? So I'll give you 2 minutes back. Yeah. Sorry?
Will there be a Noir token? You don't have to answer that.
Is the result somewhere? Will we push it somewhere?
You mean? Yeah, I can make public my like the reference contracts, this reference examples from this workshop, and you can have a look. Yeah, sure. There's just it only has some notes for me to not forget, and I still forgot something.
You said you have recursive verifier.
Yes, the verifier verifies a recursive proof. So you make a proof, and then in another circuit you verify that proof. So you kind of prove that your other circuit is correctly verified.
Isn't that what he was
No, he was asking about verify the verifier contract be written in another language for another chain. Yeah. For example, for Solana chain. Yeah, this is Solana. Yeah, this is Solidity. Yeah.
No, I'm saying like in Noir, you're recursively verifying. So that verifier is sort of a verifier.
Yeah. Yes, you could get it from there. Yeah, I guess so. Yeah, I'm probably lacking the specifics, but it makes sense. Yeah. I mean, Noir is written but the recursiveness is implemented in the backend, which is C++. So, yeah, again, Noir doesn't do anything. It just compiles to ACR, and then you run the ACR. And so this is what we call the black box function. So if you go here and you give recursive proofs here, given an example, it says this is a black box function, and this basically says that this is provided by the backend. So if you get that from the backend, which is Baratenberg, at least the default backend, that's going to be, the verifier is going to be implemented in C++. So not Rust.
What are the main differences between Noir and Cellcom?
The main differences.
Why should I not use Cellcom?
Yeah, I mean they are different. I would say that Noir is very powerful because it's very easy to write, and yeah, that's basically it's the main. I think it's a matter of like ideology. What do you think about it? But Circum is a great language as well. It's like for our purposes, we wanted something that's really really easy to work with, and Circum, it's not. Yeah, it's okay, but it's not as easy as Noir.
It's like us composing hardware.
Yeah, it's more like writing circuits. Like I used to draw circuits and then connect the wires to make Circum. And this is a way of thinking that it's not common to engineer like engineers to programmers, and so. Yeah.
And the differences between Cairo and Noir, because they are very similar.
Yeah, they have similar goals, I would say, right? But maybe I'm wrong here. But I would say that Cairo is more for succinctness because it's basic for Starkware, for Starknet, and so it's not, the privacy is not built in. Maybe there's some kind of plugin or something you can use it, but it's not built in the language like in Noir.
Okay.
Yeah, we need to close. Cool. Thank you for coming, and I'll be glad to talk later.